जन गण मन अधिनायक जय हे। भारत संविधान भारत भाग्य विधाता। जम्मू कश्मीर हिमाचल पंजाब हरियाणा राजस्थान दिल्ली यूपी उत्तराखंड बिहार गुजरात मराठा द्राविड़ आंध्रा एमपी केरला कर्नाटका तेलंगाना वंगा विंध्य हिमाचल तावी यमुना गंगा कृष्णा ब्रह्म सरस्वती ब्रह्मपुत्रा। तब शुभ नामे जागे तब शुभ आशीष मांगे। गाहे तब जय गाथा सर्वधर्म नागरिक भारत विधाता। जन गण मन अधिनायक जय हे। भारत संविधान भारत भाग्य विधाता। जय हे जय हे जय हे जय हे जय 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 जय। जय भारत सुजलम सुफलम मलया शीतलम सासया श्यामलम मातरम वंदे मातरम। जय भारत जय संविधान। Good morning. This is 10th March 2020, another day of Holi festival also this year. Holi, a good festival for colors, but this year it's sad that many people have been killed in Delhi and elsewhere. So it's no use to talk of daily celebration of Holi. Well, continuing talk of project management, construction management, quality system. Construction management base is based on quantity and quality. I've been talking for long about management in construction. Practical management I am concerned with. I am not concerned with book management. Books can be written by those by imaginations, but those people who are well experienced in management, they have not written many books. Yes, there are people who have just nothing to do management, they can write books. They can write anything. That is nothing to do with construction management. Construction management involves money, it involves resources, it involves lives of people, it involves a lot that those people do not understand who talk of management. Management of construction means 70% of your earnings go to construction. You may know that, may not know that. Once you buy a flat or an apartment or some house means all your life savings are involved with that. If you are middle class, if you are very rich, I'm not talking of that. Then money is nothing for you. It's like store. But if you're middle class, lower middle class, or an ordinary janta or very common citizen, money is very significant for you. It holds role for you. And even a single unit of money, a unit of currency, rupee or whatever you have, dollar or sterling, it concerns you. And if your money is thrown in construction as if it's nothing, it's just a dirty water, then how do you feel? I know. Every unit of money should give you return. Return doesn't mean in case of profit. No, it's not profit. It means use of commodity that you're buying, and you're buying something which constitutes materials, equipment, human resources, and that should serve you for your requirement. And that requirement, use of property. So quantity and quality are very significant issues. We are concerned with quantities in our country. We are not very much concerned with quantity with quality. Quantity plus quality equal to quantity according to my understanding. I do not consider something quality less to be quantified. Quality less item cannot be quantified into product. This is my definition. I consider something delivered only when it is based on quality and quantity. Otherwise, that is rejected one. I can't even accept substandard because I am not paying for substandard. And you cannot have compromise with me. This is my consideration. So, management of Construction means management of design, management of working on site, management of every factor coming into construction, field, involving real estate, involving infrastructure, involving water resources, involving environment, involving whatsoever. Your money should come back to you in form of quality product. But it doesn't happen because of your innocence and available no awareness among people, common people who do not directly deal with such activities. For that purpose, I am here to just talk to you about what happens in field and what happens indoors, which you people are not aware. You are well aware about other professions like medical, like chartered accountancy, advocates, and all others. You well know about them. But about what happens in projects which cost billions and billions, you are capped off because of whatever reason. You are not aware of that and you just see what's happening. That's fine. What's happening, you see, you look at. But what is happening behind curtain, you are not aware. Behind curtain, there's 90, 80 or 70% of activities that move on your scene, which you see only few percent of activities are done. Lot of planning is done, lot of thinking is done, designs are done, coordinations of designs are done, drawings are made, specifications are drawn, contracts are drawn, activities of course are required, and so much go on for double or triple duration than your construction duration. If construction takes 1 year, behind construction, before construction, it may take 2 or 3 times of that period that people in general are not aware of. I have talked to many intellectuals about our field which you are not aware of. You know what a doctor does, everybody knows. Everybody knows what a lawyer does, everybody knows what a judge does. Everybody knows what all other companies, secretaries, chartered accounts, and IES, and all those are others. Common professionals, I call them. They're not very high skilled in comparison to what engineering requires. Engineering, I should say with claim, that most difficult education, particularly for those 3 or 4 branches. Those are originally basic branches like civil, electrical, mechanical, minimum, and imaginary architecture. These branches give you something in hard work, in hard delivery. If you are born somewhere as baby, you are born certainly in certain smallest hutments or in a biggest house, palace, or wherever. Rarely people are born on footpath. Generally 99.9% people are born in certain covered area. This means you are born in a product which was delivered or is delivered by engineering mechanism. So when you die in certain hospital, that too is a product. This means your whole life is involved with a product, with certain good that is a product of engineering. So we should think this in that fundamental aspect, not in a way that we have to commercialize this and get some benefit. I was a student of engineering, everybody is, and there are so many millions people who had been student of engineering, and that engineering doesn't mean engineering alone. That was just A, B, C, D of engineering world. Engineering really starts in your field when you come out and start doing job. That time you know nothing actually. You know nothing, very little. You're starting. Your starting field means you'll start learning of that. And it takes many years just to know something. And when you combine to your academic education and your experience in field, that teaches you something. Yes, I learned that. Actually, 100% of the learned there is not used in field. In the field, you have to learn practical work. That is where you are at examination. That academics examination you can pass. Once you enter university, certainly you will come out with certain percentage of mark, which only tells that you know this. You can enter this door and can stay in that, means that is a door for your future. So you have to understand that it's not that easy as we take. You need a job, that's fine. You want to make a career, that's also fine. That's your right. You have to move forward, that's also fine. But question is, what your role is. Role is very important. What is missing in our country is definition of roles from top to bottom. From top to bottom. From all whosoever we are, roles are defined or not defined, it's up to us. We have to define our roles, engineer's roles, because engineer means development, engineer means change, engineering itself means change from material to delivery of unit or delivery of certain good like building infrastructure, which can be used for coming decades. We have to do that one in open sky, not in closed doors. We are not working on small machines to produce machine parts. When mechanical people do that, electrical people support all them. I am talking of construction engineering, which is based on designs and it gives you benefit of use. So we have to be very clear about this. What we are talking, what we are doing. If we understand once, we can move our country with quality system. Our country is missing quality system very much. Quality system, I'm not talking immediately of ISO 9001 or Sigma or some other. I am talking general. Our concept, our mindset does not limit to quality, but with no consideration of quality, let it move as it is. That is our approach. Though we have every certification, we have every document, but that is only in files, on walls, postings, not factually it is done. You go to market and buy whatever product you want. You will not find what is mentioned on the product, how it performs. They will write anything, but you cannot be sure of that. Example is a mouse even. You buy a mouse of computer, you will find on that a prescription that it will work for so many millions clicking. Have you ever noticed? What is specification of mouse? What is its performance mentioned? It says many clicks, means let us say millions of clicks, so many millions. I just bought a mouse, say it's written it will give you 4 million clicks on now. Now my question is, did they try that? Did they click 4 million times on mouse to test it? Nobody did that. Person cannot. This means it is just a statement for sake of statement, of nothing else. So are we living in this world for statements, or are we living for some concrete achievements? That is what I say. We have to think in different approach, in completely different approach. Let us, for example, take a brick int, which is a small unit. What do we think of that? We think we have used thousands and lakhs of bricks in this house. Yes, you use lakhs of bricks. But do you know what is brick? Why do we use it? What is function of brick? Why don't you use something else? You never think of that. But you know that stones were used long back. Stones were used. The stones are very good, far better than bricks. Why do you use bricks then? You have no answer. No answer, yes. Stone comes from rocks, but brick does not come from rocks. Brick comes from soil, and that is clay soil. Clay soil, that is not very good for building, but it's good for agriculture. Well, that is also another topic. My question is, What do you know about brick? How it is manufactured? How it is produced? Have you ever thought of? You have never thought of. Yes, you may say it comes from brick kiln. Okay, it comes from. Have you ever seen that kiln? No. Do you know what's in brick? It's clay soil. You know very well. Now, clay contains so many minerals and impurities as well. Okay, keep that afar. You got a brick. Have you ever tried to know it's right or it's not for quality? You have now tried to know. You will find brick when it's very distorted sizes, not equal dimensions, very rough surfaces, and many impurities. And if you keep a 1 meter high and drop it, it breaks. How much water it is absorbing, what dimension it should have, what type of sound it should give when two bricks are rung together or hit together. You have never tried that, but you just say, I bought a brick and use that. This is a problem. That's all, nothing else. People say this house is a unit, building is brick. Building unit is brick. Okay, we consider brick, right? Forget RCC. But you don't know what brick is. First of all, you have taken clay soil, means it's already against environment, fine, forget environment. But you don't know something about that brick and you use lakhs of bricks and millions of brick in your project. That is where I'm talking of. All buildings in general, in common, are using 80% of quantity of bricks if you consider all material. This means you are taking soil from earth, clay soil that too, and installing in your building in form of bricks. Everybody is not bringing machine made bricks. People are just bringing normal bricks, which does not have, these bricks do not have dimension, whatever is required. Surfaces are very bad, porosity is too high, and mainly these are either underburnt or burnt. If you just drop this brick, this means you are not using quality bricks. This is a fact. Okay, this is brick. Now, you don't know what sort of mortar should be there between these two bricks. That also you don't know. You just put on way mason does. And nobody checks, nobody points out, and nobody is concerned. We just do it, and that's it. This is our technology. This is our technology because mason is technologist. This man who is spending money, he is also technologist. Both are engineers. Without being engineer, they are engineers. And you are honor, you accept everything. You don't know what to be done in earth, what to be done in pit, what to be done in foundation. You don't know anything, but you do. It's not your fault. I'm not saying you are rough. You don't know. You're unaware of that. Whose job is this? Those guys are not available there. Same question arises for other items. Okay, brick is very old now. Stone masonry has gone. Stone masonry is much stronger than brick because stones can be of many types. If you use igneous rocks, stones, it is very good. But it's not available and it's not, very common these days. What is common these days? These days common is concrete technology. Concrete. If you define concrete, it's very difficult and very easy both way. First meaning of concrete is something solid, something reliable. That's meaning of concrete. If you open dictionary and you will find meaning like that. Oh, it's very reliable, very solid. Something means which can be relied upon. That's concrete. And what is concrete? In fact, in our construction language, in as material, if you define concrete, what shall you define? You may say it's an artificial stone which has been produced by combination or mixing of various ingredients, and those ingredients are, you can say, aggregate, stone aggregate, various sizes, dust, stone dust or rock dust, or sand, pit sand, or river sand, or you can say then it is cementing material like OPC, this is called ordinary Portland cement, or some other types of cement, and water, H2O. You can say combination of these various materials in various proportions is a way to get concrete done, which is wet, and then it after chemical reaction is hardened, and that is called artificial stone. Yes, it, to some extent this is right. This is a process based definition. And there is steel reinforcement, people call it steel. The, okay, steel reinforcement it is called. Why it is used, you also don't know about that, but there is a definition of that, there is a complete explanation of that, why we use steel bars or so-called rods. Because concrete has a deficiency in certain force, it cannot take, it cannot resist. Certainly there are two types of prime forces and others based on those prime forces. One force is direct, means compression. One force is, if you pull something, this is tension. Tanav, dabav, the two forces. Compression is dabav and tension is tanav. These are basic forces. When ordinary force applies in axial direction or in straight direction without bending that material, and then material is bent, so there are various other forces generated which I'm not going to talk. My issue is only my specific statement is that because concrete is good in compression, it's not good in tension. In tension, we to just take that tension, we use these reinforcing bars. This is simple requirement, just for your explanation. There's so much on that, but I have, this is not time in this talk because this talk is related to quality, which we'll discuss later on. We go on taking how to ensure quality management, quality check. So we are saying, I am saying that steel reinforcement is inserted in concrete, so it's called RCC, reinforced cement concrete. Before it was cement concrete, now it is reinforced cement concrete. So this is a composite material having one solid material having many ingredients and another material which is factory produced, and that is reinforced concrete, which is having many grades, and result is RCC. This RCC is general material used in structures. You can go and see whatever structure. You can say building. You can say you you can say manholes, of course, sewer line, and you can see metro, for example. You can see railway buildings, or you can see certain other heavy structures, factories, industries. Somewhere you shall find RCC involvement. RCC involvement. Even if it is a structural, still foundation is RCC in RCC structure. So it is very much reliable material. Your associate for your life, in your house you sleep, on your factory you work, or wherever you go, you'll find your friend RCC with you everywhere. When it's your friend, you're both related together, you owning this friendship with this material, then why don't you have good friend? Why do you have worst friend? Why do you have friend which cannot help you, which can kill you, or which can bring you to danger of collapse? This friend is for decades together, for centuries together. Why don't you have this friendship with this material in very relative way? Why just to ignore this? This is what I want to talk about. Quality is very significant in your life. Even if you go to a market to buy small item which cost maybe few hundred rupees or 50-60 rupees, you check quality of that. Whatever you know about that, you check it. But you are not very much concerned about whole money you spend on something, whole life earning you spend on something. You are not too much concerned for that. This is pity. This is pity. Engineers are very good people. They can be used in an excellent way because they are highly educated, highly qualified people. Maybe most of you, many of you are not aware about engineering education in civil construction, in mechanical and electrical. Civil is maximum calculation field in many subjects. Subjects are first of all scientific calculation. It's not mathematics alone I'm talking. Mathematics is basics of civil engineering. There are material engineerings, theory of structure, applied mechanics, strength of material, I can say, and designs of structure. These are subjects which make one mad. Such complicated calculations are done for months together, for years together, that one mind's break if not powerful. But those calculations work very well if you design something, if you apply something, if you use some material, and you imagine and do something to practical world. These calculations are very reliable, but people are not aware of that except those who either teach or who learn, these students of engineering. Imaginations based engineering. For example, we study a beam is little down, is deflecting, but you do not understand that because you have never seen beam coming down except when structural collapses. You have not seen column little bending, and you have not seen slabs little sagging or hogging, but it is considered. It is considered in ordinary loadings as well as during earthquake loading or wind loading. Wind makes building dance, it starts building, it vibrates building. Earthquake forces do vibrate building. These do. Direct load, of course, impacts on building, and its weight also impact on building. These are all imaginary but practical. Just like there is electrical current flowing in wire, but you can't see that. But you see application of that, and you put bulb or tube or something in that application. You know that it works. Therefore, if bulb is on, electric current is working. Same way, if building is alive, various forces are working on that. They never stop once building works serves for you, and that service is unknown to you, but it works for you. You may know or you may not know, those forces work all time, from soil to top of your building, during normal force, during wind or no wind, during earthquake or no earthquake. All these forces work for you. You have to realize that situation. It's not simply dead material, it's working material. Just like I work and you work, these two work. Two capacity which you have put in there, you are inserted into that material. All these materials work for you. We have to understand this philosophy. Building is working system for you, just like computer is working system for you. You cannot get service from building which it is not designed for. And when it collapses, this means is that there is some error in that design, and some incorrect application was done. That is result, which is collapse. We should understand ourselves this way. For example, in general, there is a placement of steel in certain directions in an ordinary slab which is having supports and which is not having support. Both are different positions. Which is not having support, we call that cantilever. In ordinary language, called chhajja or balcony. Means which it has only one end support and other end is free. So there is different direction of these bars, while when it is supported, direction is completely reverse. This point people mistake, those people who do not know this. Well, I am just giving an example. This example is not perfect, just for an advice it is. That you have to understand what is business and what is profession. Profession of engineering is not known to people because people cannot understand what is meaning of profession. They understand a profession means only earning money. No, profession doesn't mean only earning money. You have to advance study. You have to go on studying in depth and in advanced levels. That's called profession. You have to learn theory as well as practical, and much more. You have to keep updated with whatever development moves on in profession. That is called profession. It's not simply money making, or it's not simply passing degree and lock up yourself, or you say that I have passed it and done it. No, it's not that. Profession, because technology keeps on developing, formula keeps on developing, methods keep on developing, new materials keep coming in, and we have to understand, we have to educate ourselves what characters, what parameters those new materials are and new technologies are, and then we have to apply them in our field. That's called profession. Means profession never stops at whatever age you are. Till you die, you can work on profession. So engineering profession is very different. It gives you something reliable, from a very smart part to whole structure. That point we have to understand. This management is excellently and very different from other managements. When I say project management, it doesn't mean only management on site of project or in factory. It means management in totality. Totality of thought, totality of design, totality of application, and totality of management. All total must be there. When your money is gone, you should get the material back. Otherwise, your money is lost, I should say. You cannot compare every item in money power. You have to see how that material or equipment, or you can say system, is worth for your life. You buy a cycle or a scooter or a car, there's a fixed life of that. You buy a computer, there's a fixed life of that. Oh, for my computer is 5 years old, 10 years old, now it's no use. You say that because of change of technology. Similarly, you change your car because of technology, or many new supports come in that car. Same way for your whatever you buy a shirt and throw it after few years. But this item of engineering production in civil structural engineering works for you for decades, and for in some cases centuries, if it is possible to do that by retrofitting your structure many times during that intended period of 50 years, 100 years, 150 years. Examples are there. You can say there are many old structures, like in Egypt. It is more than 4,000 years old structure, more than 4,000, and still they restored that. Pyramid, they restored that. We have to take it into our consideration. Red Fort in Delhi, Taj Mahal in Agra, Qutub Minar, Eiffel Tower, and many more, which have been for more than many centuries and still alive. This means there was some structure, there was some quality content which is not documented but was inculcated into those. We have to be very clear about that. What happens in the year? You just construct a building, and after few years it sinks or it cracks. This means what? If your building collapses in 10 years or 5 years, or there's a failure, where is quality? Point arises. This means in modern age, we those who do not know what professional engineering is, we just do not care, and we lose money and life, because money and life has no value, and we do not care for profession or for quality, and result is that we lose material and we lose human life. This happens. That's what I am stressing, that open your minds and eyes, that there is a service provider, and that service provider is called engineer. We know there are engineers, but we don't care. I am not talking of law, I am not talking this, I am talking of service. If you have a body, you are sick, what you do? You certainly go to a doctor for treatment, or you admit yourself in hospital and have treatment. When you are in problem of some dispute, you go to a court through lawyer. If there's a problem on your accounts, you go to chartered accountant. There is channel for everyone. For everyone. You go to them and solve your problem. But only there is one channel which is not used, that is this quality of product. You do not understand this, on which you spend whole your life, and that is engineering service. I'm not telling because I'm an engineer. No, it doesn't mean that. In factories, production is automated. It may be mechanical factory or some other parts factory or some other processing factory or plant. There everything is automated and well designed. So there's only reproduction where computers reproduce or robots reproduce. Why isn't in millions of items are produced, of course, contained with quality. But where laymen are working, where human resources are working, who don't have very academical skills but work skills, they work there. Many thousands and change on these activities. There, can you expect that sort of quality that production of automation gives? No, you can't expect that. That is where I'm focusing. I am focusing on sites where construction is done to produce some systematic structure. Systematic structure. A structure is produced and that structure carry with this all finishes. If a structure is reliable, finishes would be reliable. And reliable means it should work safe, it should work, it should serve you for which purpose it was done, it is done, and it should work for defined duration, that's called durability. Reliability means what I say, reliable equal to safe plus service plus durability and plus whatever else you want to add to this, you can add to this, no way out in. That's what I'm saying. You have to think in completely different way if you want to achieve quality and goods. Quality plus quantity. Quantity plus quality is product. It's not simple quantity alone. If quality you don't have, this product is rubbish, useless, no value. If you do not make your mind like that, you cannot do it. Just by only speaking, I can't do it. You have to do it. And people do it. In other countries, they do it. Only in my beautiful country, we avoid it. We say, oh, no problem, chalta hai bhai. Why? Why do we have different thoughts? Why can't we accept our errors? Why don't we feel shy? Why don't we feel shy? If there's some complaint, okay, we will ensure, we will check. Well, this much comes to you. This comes to you. Or we will see there's some problem. All this and this. Why shall you see there is some problem? Don't you know what is problem? You should know you are selling it to me. You should tell me this is problem and compensate me first for that and then repair it. Does it happen? No, it doesn't happen. This is why more important in this world in 2020 that engineers should be more proactive. Don't think somebody should come and teach you. You have to teach yourself because you are producing some product when selling it. If you are not selling it, someone else is selling it. You are supporting that one. That's what we say it is to be done. Can you do it? Quality on construction is fact that it's rubbish in general. It's rubbish. I don't understand reason behind that. You cannot even say it's 50% quality. I think it's negative quality. Negative. Because concrete is involved. Concrete element is more than 90% activity-wise, work-wise. And it's not quality product all over. Except precast yard or something. Whatever is done on sites is not quality product, because it's not being formed, it's not being done, it's not being, you can say, followed up. You yourself go to some site and see. It may be whatever site, irrespective of ownership. You can yourself see. If you are an engineer, go and see what you are doing, your friends are doing, your fraternity is doing. You will feel ashamed of you. I think no other country has got so many engineers, so much strength of fraternity of engineering in other world, in other country that we have. We have plenty of engineers of many levels, diploma, degree, post graduation, doctorate, and all, and professors, teachers we have. But what is use? What is use if we cannot control production? We have excellent design engineers, excellent, in thousands, many lakhs, we can say. We are very good designers. We know software very well. We produce very good calculations. We produce very good designs, and we do it. With hard work, we do it. But we stop there. We stop after that. Architects do very good designs in conception, in imaginations, without knowing how shall it be done. How shall this design be converted to structural mechanism? Architect fraternity doesn't know that. They only know, I want this type of volume, this type of envelope I want. You do me this way or that way. They have their world. They don't understand practical applications, practical aspects of structural engineering. And structural engineers just do themselves. They don't worry about what shall happen on practical execution. So these three, architect, structural engineer, and other engineers and site, have no relations, no professional working relations in coordinated manner. Yes, there is dispute, there is friction, it doesn't work in field. If your design, if your structural design is not transformed into reality, then there is no meaning of structural design. It's same way, if you do not learn anything in engineering and pass out, or if you learn something and pass out and you don't apply that, it is just a paper you post on your wall in frame, and that's it. Because this paper doesn't claim you are engineer in practice. This certificate doesn't claim that. It only claims you passed, that's all. Not even if you are gold medalist, doesn't make a difference to work. Because your university doesn't say you are practical engineer, it says you are bachelor, master, or philosophical engineer. Not more than that. Is it more than that? You have to prove on project that you know job. And this requirement I learned from field, from other nationals, when they challenge sometimes. Oh, you are saying I am this level engineer, prove it. Prove it. Otherwise your certificate is useless. That is called understanding. That is called what they understand by engineer. If you are sleeping at home and you say I'm engineer, sleep at home, go. I feel shy. When there's some comments like this, you feel shy or not? This means our engineering education is only education for academical purpose, not for engineering purpose. It is part only. It's not full. When you come to field, you have to learn another education for many years. So that degree of a university and this side degree, if both combined, that is called engineering. Academic engineering means from university or from institutions plus learning degree from field equal engineering degree. It's not university alone, B.Tech, M.Tech, etc. that calls you engineer. No, you are only student, certified student. You passed, student engineer. That's all. You have to learn more in field to make you engineer. So keep in mind that you are incomplete and you have to make yourself complete. Quality is very difficult to attain. Sometimes whole life is passed and quality is not understood. And sometimes few years give you training and you understand quality. This is only definition of quality. It depends upon your personal interest, upon your involvement in quality, that you value quality, and then your product is different. Your product claims that I am quality product, then your product shall claim that it's done by professional, or otherwise it is scrap. Concrete means solid, simple. That's why this translation is concrete means solid, means it should be solid. Solid means having all properties, all quality within this. Otherwise, it can't be solid, it will be fluid. Now, I am not able to speak a lot to define what is quality. You have to use your mind yourself and define for yourself. You as an engineer, you as an owner, you as public person. You have to define yourself what actually you mean by quality. Quality has different meanings at various locations. For someone, attraction of project is quality. Oh, what a beautiful building. For them, this is quality. For one, no, I want very strong structure. For me, this is quality. That's right too. If you keep off money making from your mind and think of future of this product, that's quality. Quality is related to use. Quality is related to environment. Both. And quality is related to reliability. That's also a point. It's related to how you optimally use your resources. Quality system that we follow or we are required to follow is ISO 9001 2015 we talk of, or Sigma or whatever. I am inclined to talk about ISO 9001 2015 in particular on our construction management. I have talked of that one in general and also for RCC buildings contracts as well as for EPC management of civil engineering works and plants, etc. These I'll just refresh it so that you can know what I mean about. ISO 9001 2015 is not something extraordinary, you can say. It is just a system. Before this also quality was complied with, before it was done in BS standards or in some other standards, they are available. ISO 9000 came later on. It is a system. It's a compilation of systems, of practices which you are used to be, and later on it used to develop further and further and further. Quality was followed before also. Actually, if you see, before ISO 9000 came into being, quality was much better because personal involvement was there. Responsibility was shared by people, by engineers, but this quality actually fractioned into many disciplines, which is also good as well as bad both way. Means particular responsibility is fixed. That's nice. So we have to follow that. It came long back, then it was 2008 and now it is 2015. It's very good as far as responsibility is concerned. liability is concerned, job description is concerned. But what we understand by that? They define something which you have to accept, because if you follow them, if you want certification under that compliance, you have to comply with system requirement. And you have to support with your own system, which you say, yes, I have to add to that. That is quality system. Means their definition and your further definitions, which you have to practice if you want to continue under that certification. That is called international standard. Well, it's very nice, but just you follow it on papers and not in practice, it has got no meaning. Generally, people follow it. I have observed they follow it in practice, and some people don't follow in practice but on papers. If you follow in practice, it's very good. If you just compile papers to prove that we are following it and it's not resulting on site, site doesn't tell that, then system is incomplete, though you have certification. Certification doesn't mean your product is good. That's what system says. But when you follow a system, your product should also claim that I am good. That's what quality says. Both should reciprocally tell each other that we are working. I am working, you are working. If your paper is okay, your signs are okay, everything is okay, but result is something else, this means you are stealing, you are cheating. You are cheating. And the other way, papers are not fulfilled, but work is fulfilled. That is not cheating, but incomplete documentation. This means documentation and work are together. If there is work, it should be based on certain inspections and checks and scrutiny, and that is called quality management. It's not simply paperwork. It is paperwork and real work. If you can understand this, you can understand quality system. Otherwise, for you, it is a system only, nothing else. It is a system just to advertise that we are qualified, we are certified. I am not interested in that alone. Your product should say, yes, I am quality product, just like you say, I am quality engineer because I know engineering, I can do it. I am quality medico, I am quality advocate. If you say that, you must be. Or you say, no, I am only graduate, I am postgraduate, I have certification, but I know nothing about this. It's not quality professional then. Engineer should convert to quality engineer. That is a requirement these days. It's not simply statement in degrees forms. No, product form. You should state that you are a proven professional. Just like a professional building should speak, I am professionally worked upon. I was constructed in a professional way. Building can speak, your structure can speak when you go and inspect that. Or if you just go and see new building after 6 months, cracks are coming in walls. You see settlement of wall is there, plastering is peeling off, paint is distorted, there are some cracks at corners, slab is broken. If that kind of work exists, how can you term that work quality work? We have to understand this point of view. There is system agreed, but that system is in your hand, not in ISO 9000 hand. They are just advising you, they just define to you what you have to do, but you have to define yourself in details what you have to do. If somebody certifies you, doesn't mean somebody certifies you because of your submission, because of your declaration, your affidavit, that, and of course there's random check indeed, yet nevertheless it is your responsibility. You may be owner, you may be engineer, you may be contractor, you may be whatever. It is ultimately your responsibility. Every engineer must know this. You are engineer only when you do something. If you don't do something, don't call yourself engineer. Don't call yourself. No use, you are just giving bad name. You are misrepresenting. Do something. Your work should tell that you are engineer. And because Major portion of people in engineering are involved in government sector as in private sector. Half are probably, I don't know how many percentages. Both are responsible. Those people working on front line management, they are adding more technically. They should know job up to chief engineer level, up to highest level. If one is engineer, one be engineer in reality. You cannot pass any excuse to others because you are a specialist. When you are working in field, you are a specialist. You are working on certain items and repetition for many, many years you work there. If you have been working in buildings, you work for many years. If you are building other structures, other infrastructure project, other projects, you work there for years and then you are a specialist. If you can earn a degree only in 4 or 5 years and you work for 20 years on something, you must be very expert. Degree is very small in comparison to experience. If you compare experience to your value of degree, means your experience should have more weight. And that can be proven only if your experience produces reliable products, quality products. And that is where ISO 9000 requires. Otherwise, there's no ISO 9000. What it says is this definition is very clear. I have spoken it many times, yet I can say again that ISO 9001-2015, which actually is nothing but a guideline. It was a guideline before, it's another guideline for quality system. I already told you again, just for refreshing for those who have not heard before, an organization, which whatever organization it is, it adopts certain management system to take care of comfortably achieving its set objectives. Whatever objectives you define, that's where I speak objective. Your objective, whatever you define, you have to take care of that very comfortably. And that management system comprises various sets of procedures to chart out and implement various operations or activities so as to successfully reach its intended objectives, which leads to enhanced use of resources. Means if you are using 1% resource, then you have to add to that percentage. Enhanced use of resources means you should get better return from your resources. Improvement on risk management, because every project has some risk, every investment has a risk, so you should improve on your risk management and increase customer satisfaction. This is what is required. Increase customer satisfaction, and once it is increased, then further increase, and then further increase means your customer is one of your targets. You are delivering your service to your customer or to your owner or to your promoter or to your end user, your products end user, not your end user, I'm sorry, your products end user. By meeting product or services expectations, every product has to provide service or use. You have to upgrade that one so that service is given further better. Now, organizations do work on various management systems. For example, quality management system, environment management system, and safety management system, and many others. I am now constraining to quality management, environment management, and safety management systems. These various systems in line to ISO 9001-2008 used to work on varying management structures, causing inconvenience to interface with each other. It is about past when we used to get work on to 2008, 9001, 2008. There were some clashes among these systems of three, as I said, quality, environment, and safety. There were certain clashes on formats, and to just eliminate those clashes or contradictions on these formats, ISO 9001-2015 has been brought in. Now Now NXSL, as we call it, NXSL being high level management system, it has produced a common platform for all these systems to integrate in any organization. So as all systems that organization adopts can be drawn based on Annex SL designs or its format. Now this arrangement provides commonalities, many commonalities, common definitions, common structure in designing whatever system you want to adopt, its implementation, systems monitoring of performance, its evaluation of performance, its improvement later on, and by trying to eliminate conflicts that existed within ISO 9001 2008 system, which has gone now. It is gone now. Now all these management systems shall have single high-level identical core tags with common terms and definitions. High-level structure cannot be changed. Just remember, whatever clauses are given, whatever definitions are given, this cannot be changed. But whatever disciplines you adopt, you work on specifically, particularly on subclasses, you can add, you can replace, you can change, but main cannot be changed. Annex SL applies to all management system standards, publicly available specifications and technical specifications, means you can incorporate all those whatever is available on specifications history, on specifications background, and technical specification. You can use all that, integrate with Annex SL format. So you can say this high level Annex SL high level structure shall work everywhere where ISO 9001, 14001, and 45000 work for you. So its structure, you can say there are three columns in that annexes. Just for your refreshing, I am telling you, many times I have explained to you, but it's better to take 2 or 3 minutes to explain to you. There are 10 clauses in this structure Annex SL, and then these clauses, say in first column it is clause number 1 to 10, clause 1, 2, 3, like that up to 10, and then there's a format title and there's description of that. Now in class 1 format title, it is a scope. In class 2 format title is normative references. In class 3 it is terms and definitions. In class 4 it is context of organization. In class 5 it is leadership. In class 6 it is planning, and in class 7 support, and in class 8 it is operation. In class 9 it is performance evaluation. In class 10 improvement. So I repeat from backward. Class 10 improvement, class 9 performance evaluation, class 8 operation, and class 7 support, class 6 is planning, and class 5 is leadership, class 4 is context of organization, class 3 is terms and conditions, class 2 is normative references, class 1 is scope. And in a scope there is a description requirement that is called PDCA, means plan it, do it, check it, act on this. Do you understand that? PDCA. P stands for plan, D stands for do, C stands for check, A stands for act. So PDCA, plan, do, check, act. Now in class 1, when it is scope, what it requires, intended outcome of management system. When we are saying what's the scope of the system, outcome of management system, which are industry specific and should be aligned with clause 4, that is context of organization. So clause 1 and clause 4 are related. Now if you go to clause 2, which is normative reference, it says it should do details of reference standards or publications relevant to particular standard. You have to define references which you are going to use or which should be used. So this is ordinary. When you say clause 3, this is terms and definitions, which says detailed terms and definitions applicable to particular specific standard in addition to format related terms and conditions. So then we come to class 4, which is context of organization. What actually it includes means you have to understand. Understanding organization, its context, first of all, you understand what is organization, what it intends to do, what's context, and that is understanding needs and expectation of parties. There are various parties in that. You have to analyze needs and what actually these parties do expect system to produce. Then determine scope of management system means one article of clause 1 determine scope of management system, and then number 4 management system. This is what clause 4 speaks for. Now class 5 is leadership, and this is leadership and commitment, policy and organizational roles, responsibilities and authorities is what it says. Now it is long in that, so let us go further only because I'm just hinting to you. Class 6 is planning, which says actions to address risks and opportunities, management system objectives and planning to achieve these objectives. Then support, it is class 7, and support, you know what support you get? You get support from resources, support from competence, support from awareness, support from communication, support from documented information. If you go to clause 8, then you'll find that operations, which say operational planning and control, points for considerations in which are in-house process, outsourced process, overall process management include adequate criteria to control these processes and manage planned and unintended changes and various other operations which are mandatory for your system. Clause 9 is performance. Now you have produced something, how it is what you are working on, how you are performing on. Monitor it, measure it, analyze it, evaluate it. Monitoring, measurement, analysis and evaluation. Internal audit and management review. That what you are the clause 9. And then clause 10 improvement. When you work something, you perform something, of course some non-conformities are expected. So non-conformity and corrective action and continual improvement, that is clause 10. So what is clause 1? Clause 1 is scope. Very good. Clause 1 is scope. Clause 2 is normative references. Clause 3 is terms and conditions, and clause 4 is context of organization. Clause 5 is leadership. Clause 6 is planning. Clause 7 is support. Clause 8 is operation. Clause 9 is performance evaluation, and clause 10 is improvement. These are NXSL structural levels. Now, two most important objectives in revision is that to develop a simplified set of standards that shall be equally applicable to small as well as medium and large organizations, and for amount and details of documentation required to be more relevant to desired results of organization, process, activities. Now, ISO 9001-2015 Quality Management Systems requirements has achieved these objectives, and purpose of this writing, okay, I'm just going to speak something about documents here. ISO 9001-2015 allows an organization flexibility in the way it chooses to document its quality management system, QMS. This enables each individual organization to determine correct amount of documented information required in order to demonstrate effective planning, effective operation, and effective control of its processes with implementation and continual improvement of effectiveness of its QMS. Now, what is documented information? Definitions and references. What actually we have to understand? Term documented information was introduced as part of common high-level structure and common terms for management standards, MSS, and high-level structures, HLS. Now, definition of documented information can be found in, well, that is reference one. Documented information can be used to communicate a message provide evidence of what was planned has actually been done, or knowledge sharing is. Documented information can be used to communicate a message to investigate a message to a person who who orders it, or who scrutinizes your system. Provide evidence of what was planned actually has been done system. So it is knowledge for you. Now, some main objectives, what are these? Say documented information, I'm talking of in simple language. Communication of information, it means as a tool for information transmission and communication. As a tool for information transmission and communication, type and extent of documented information shall depend on nature of organization's products and processes, degree of formality of communication systems, and level of communication skills within organization and organizational culture. Evidence of conformity, the first one was communication of information that we have to tell. Means it says that transmission and communication must be proved. Types and extents of documented information depend on nature of organizations and products and processes, degree of formality of communication systems, and level of communication skills within organization and organizational culture. Evidence of conformity means it should say provisions of evidence that what was planned has actually been conducted or carried out or done. The knowledge sharing is done, and then to disseminate and preserve organizational experience. A typical example would be a technical specification, for example, which can be used as a base for design and development of new products or services. Now, what I say is that now, what sort of medium should be used for this documentation? That's the point here. It says that you can use it on paper or on magnetic world or electronic or optical computer disk or on photograph or a master sample or whatever else is in video form. You can take it now on audio. Well, audio form, this means you can use where it should be. You can keep somewhere, you in clouds or elsewhere, whatever approach you have, whatever ownership or service you are using. And then the documented requirement, actually what is documented requirement? Now quality management system and its processes requires processes require an organization to maintain documented information to an extent necessary to support operation of processes and retain documented information to an extent necessary to have confidence that processes are being carried out per planning. Now, let's say what sort of that is means there are two ways. One is documented information required by international standard. This means mandatory documented information. And other one is documented information is determined by an organization as being necessary for effectiveness of quality management system. Let us say it depends on size of organization and type of activities, processes, products and services. It depends on complexity of processes and their interactions. Also, it depends on competence of persons. Now, this information that forms of QMS has to be controlled in accordance with definitions or requirements. Now what actually is high-level transfer documents? All these we are talking of are about. Now, documented information required to be maintained by organization for purpose of establishing a quality management system. Or it says scope of quality management system. Scope of quality management system, information necessary to support operation of processes, what is quality policy and objectives. Document information is subject to definitions. Now, we would say that what sort of this could be. Second category, first category is mandatory one. We have to comply with that. Second one is our own, which we can take support or we can provide this document for purpose of support to prove that we have worked according to definitions of our system, explanations of our system. And this can be, you can say in construction management or in plants or somewhere else. It can be organization chart, it can be process maps, process flow charts, and process descriptions or engineering procedures, you can say technical procedure, administrative procedure, work and other or test instructions. It can be IFCs or it can be specifications, means project specification, general specification, particular specification. It can be documents containing internal communications, the memos, the mails, the methods, or production schedules, the description schedules, or approved suppliers list, or you can say test and inspection plans in quality control, that is checklist and inspection test plans, and quality plans or site or project based documents or quality manuals, organizations based documents of strategic plans and forms. And there are all these access means also document information also subject to requirements. Now document information needed to be retained by organization for purpose of providing evidence. Now why should means document information to an extent necessary to have confidence that processes are being carried out for planning. Evidence of fitness for purpose of monitoring and measuring resources. Evidence of basis used for calibration of monitoring and measurement resources. And evidence of competence of persons doing work under control of organization that affects performance and effectiveness of events, and results of review and new requirements for products and services, records and needed non-state that designs and development requirements have been met, records on design and development inputs, records of activities of design and development controls, records of design and development outputs, design and development changes including results of review and authorization of change and necessary actions, records of evaluation, selection, monitoring of performance, and evaluation of re-evaluation of external providers and any or some other actions arising from these activities, evidence of unique identification of outputs when traceability is a requirement, records of property of customers, external providers lost, damaged, or otherwise found to be unsuitable for use and of its communication to honor, results of review of change for production or service provision, persons authorizing change and necessary actions taken, records of authorized release of products and services for delivery to customer, including acceptance criteria and traceability to authorizing persons, and records of non-conformity actions taken, concessions obtained, and identifications of authority deciding actions in respect of non-conformity, results of evaluation of performance and effectiveness of QMS, and evidence of implementation of audit programs and audit results, evidence of results of management reviews, and evidence of nature of non-conformities and any subsequent actions taken, and results of any corrective actions, and organizations are free to develop other records that may be needed, demonstrate conformity of their processes, products, services, and quality management system. What is exists, all such records are also subject to requirements of clause. This is what I'm talking of quality records, which is very significant from point of view of management. Now, point is that it's not simply follow up. Important is to understand it. I have talked of certain disciplines, certain subjects, certain projects on my own. I use this system understanding to convert to certain specific projects. For example, I try to give you how construction of RCC building is done, how construction of facilities is done. Those two specifically drawn SL, Annex SL I have submitted to you people. I have provided to you on my own. That was in last videos. It was RCC buildings and contractorship, along with second one that was facilities construction that I completed yesterday. Today I am going to tell you something or give you something about another one, and that is RCC, that is supervision, you may say supervising management, that is very important point. That is supervising management, let me just blow it up, yes. Supervising management RCC buildings construction template, and then it would be RCC designs building template. So I'm now concentrating on Annex SL supervising management RCC buildings construction template that I'm going to share with you. This I devised myself without any book or something. and I'll go through this now. Because we have talked of RCC buildings construction, we have talked of field work in plants, facilities, and lot of work we have talked of. So it's not complete field of that yet. Informative, you may say, it's good for information because based on this, we will further go on further methods and further services of this. Written records means I'll take you to those further chapters of management in this and then methodizations. Now I'm just going to speak to you about RCC buildings construction template when supervision management is involved. It is now say quality system. Now this is not very long actually, a few pages yet. Let's go this way, and I think I should stand better for some time so that okay, I'll stand when I'm tired. Now, quality system, supervising management, RCC buildings, construction. Now, I say an organization adopts a management system to take care of comfortably achieving its set objectives, which being in this case supervision. Supervising management on RCC buildings construction. What I'm talking about consultants actually, or staff of engineer or engineers act when building is done, RCC building construction is done, and that is role of supervision. The management system comprises various sets of procedures for charting out, as we said before, and implementing various operations or activities so as to successfully reach its intended objectives, which lead to enhanced use of resources, improvement of risk management, and increased customer satisfaction by meeting product or services expectations. In this case, product is supervising management, RCC building discussion. This is title of this one, means role of supervising management when RCC building construction is carried out. This is that one. Now, organizations do work on, now we are talking of different consultants. Organizations do work on various management systems, say quality, well, this is just quality management, environment management system, this is just repetition, the standard one. Now, these various systems have to be combined together just to produce something, and so that these act as common template, because 2008 was short of this, having a short, defect in that there was a question of interfacing various systems such as construction, or you can say these systems for management of that system plus and you can say environment and safety. Now, NXSL being a high-level management system has produced a common platform so as all systems that organizations adopt can be drawn based on NXSL designs or format, and that is supervising management RCC buildings construction can be easily defined within that format. So such arrangements provides many commonalities in designing system implementation, monitoring, evaluation, and improvement by trying to eliminate conflicts that existed in that system. ISO 9001 2008. Various stages related supervision, supervising management, RCC building construction can be covered within this template successfully. All management systems shall have single high-level identical core text with common terms and definitions which can be defined within NXSL. The high-level structure cannot be changed as subsections can be added, that's what I'll say, and that high-level structure cannot be changed, but discipline subject, discipline is specific, and clauses can be both added or changed. As such, additions may be made where required related to supervising management RCC buildings construction. NXSL applies to all management system standards, publicly available specifications and technical specifications, as well as customized requirements. The revised system ISO 9000, 14000, 45001 shall all be based on NXSL high-level structure where related to, in this case, though not included herein. Now, this template NXSL shown is only for indicative guidance to apprise an engineer how new system adopted by ISO effective September 2015 that has gone, work to produce organization prime quality document which shall govern whole organization quality process required by business, adding accountability shareable by business and technical leaders. Now, wherever and whatever requirements demand items can be added as sub clauses, but no deletions can be done. Purpose of this document is template is just to project quality track documented by ISO 9015 system, which is a mandate published by ISO, without which application all existing ISO 9001 2008 registered certifications stand invalid after 3 years of September 2015. Therefore, this Annex SL adoption is a must for new quality system operation globally. So say again, same clause 1, and then you can say clause 2, 3 up to 10, and the format of the all same. Clause 1 is a scope and clause with normative references, and clause 3, you know, clause 3 as it was, what do you call it, yes, terms and definitions, and clause 4 is text of organization, clause 5 is leadership, and clause 6 is planning, and clause 7 is support, and clause 8 is operation, clause 9 is evaluation, clause 10 is improvement. It's all as usual. So we'll go same way for a scope, for example, which requires intended outcome of management system which are industry specific and should be aligned with class 4 context of organization, and what actually does it state. That point we have to understand. Now what it says. Now supervising management, uh, wait a minute. Yes, sorry. Now, supervising management RCC buildings construction from commencement to completion stage. This is our scope. Supervising RCC buildings construction from commencement to completion. Then construction prosecuted by owner, appointed contracting organizations, including subcontractors. Supervising what? Supervising construction, that's what it says. Supervising contractors' work, you can say this contractor who was appointed, who has been appointed by employer actually on our recommendations, or whoever was there before us, that engineer's recommendations. Then it says delivery of designs and specification wise compliant completed building under clarification under certification, sorry, of completion per contract document. So what actually total scope here is very brief, and that is supervising management. Supervising management RCC buildings construction from commencement to completion stages, construction prosecuted by owner appointed contracting organization, including subcontractors, and delivery of design and specification wise compliant completed building under certification of completion for contract documents and regulations. This our clause 1. And what is clause 2 then? Normative references requires means where details of reference standards or publications relevant to particular standard are. Those are service contract between supervising manager and consultant and owner. A contract should be there between supervising manager or engineer or consultant and owner. There should be a management contract to supervise between first party owner and second party engineer or whatever company is there, that one. Then contract between owner and contractor. That is for construction contract was the owner and contractor. These are all references that I'm talking. Then it is ISO 9001 2015 contractors organization document. Then that is manual, what you call it, project schedules. Then it should all designs, all disciplines, all working and shop drawings, all disciplines, all other contract documents, all specifications within contract, all testing references, all as-built drawings and references, all materials and other items. Now, certain references that are very important for information purpose only says that, let us say, Euro or ACI or IS codes and various national annexes and NDFs or PDs. Now, these definitions you know from Euros, everybody of you know mainly. Now, what actually are required in that Euro for civil construction? There are 58 Euro codes. Now, what are these? You can say EN 1990, for example, EN 1990 2002, that is basis of designs. Then you can say EN 1991 1 2002, that is actions. Then EN 1991 1 2 2 002 means 2002, that is actions by fire, right? So one is basis of design, that is EN 1990 2002. Other one is EN 1991 1 2002, that's actions. Then EN 1991 1 to 2002, that's actions by fire. Then EN 1991 1 2003, actions by snow. Then EN 1991 1 2005, that's actions by wind. EN 1991 1 2003, actions by thermal. Then EN 1991 16 2005, actions by execution. Then EN 1991 17 2006, action by accidents. Then EN 1992 1112 2004, design concrete. Then 11 is EN 1992 1 to 2004, design concrete structure fire, etc. Then BSc and EN 1990 2005, etc. ACI 318, etc. IS code 456 2000, etc. NBC 2005, etc. building bylaws related to area of sites. There are many codes. Means no one, there could be 100 more. I just given here some references which are particularly related to supervising activities. Now, clause 3. What is terms? In this one more, I just remind you, I used the term that was Euro codes, ACIS codes, various national annexes and NDFs and PDs. PDs stand for published document and NDFs are nationally determined parameters of factors. That's NDFs. Because Euro code does not give those factors which it doesn't know. In every country they have their own system, their own factors depending on climate and type of that area. So those parameters are kept blank and Euro codes for those countries to fill in wherever project is designed. If they have, they can use that. They can publish their own parameters, their own schedules based on that country's designing system. So now we come to control references, that is terms and definitions, because it requires control references. Control references say daily progress report or status, memos to contractors, technical clarification, engineering clarification, contractual clarification, request for inspection, general items, request for inspection, concrete reports, non-compliance reports, material approval requests, drawing approval request, temporary work, preparatory work, permanent work, construction method statements, standard working drawings or details, quality management statements including checklists and ITPs, safety, measurement documents including safety, induction, training, upkeep, and surveillance, fire prevention and suppression. These lists that I give you, these are actually must, you can consider them as prime documents as far as terms and definitions are concerned, because these definition, documented definition, this not simply line definition given box, something practical definition that you worked over and supported by different system documents. What we say about this daily progress report of status. It's very big document, very regular document, routine document for every day. It defines what happened on site. It records that one, and this is very much useful to an extent. Minute details are concerned. What happened in past on this in document. Now, before going further, then let me see how many more types are there in this. So this is context of organization later. So I should give a brief on this better if you understand that one. So daily progress report is very standard document. Has got many requirements in that. You have to fulfill those every day from morning to evening, and there can be namely I'm just referring to you. This can be name of project, because which date you are doing, what activities you planned, what activity you achieved, how much you achieved, what machine has come to site, what machine has gone from site, how many workers you have here, how many engineers you have here, how many supervisors you are here, who is coming to site and who is not coming to site, and what inspections were done or what progress were done, what are running activities, what is temperature that day, means how, if possible, how much else you can write on that, and what any problem register or something happened there, means all the site information which can just tell you your person who is bearer of your talk, how much that can understand from this point of view, and that is system requirement. So daily progress report and status like that means every day it has to move, every day, no way, no out. Means every day something is happening, somebody absent, something is not, how much strength we have, what progress is there, meeting was done or not done, when submissions were done or not done, all that it has come into picture. As much as you can say, you can record for purpose of reliability, then it's okay. Otherwise, that problem continues. Then we have the memos to contractor. That's another point. Memos to contractor means engineer or resident engineer shall keep on writing to contractor regarding whatever issue arises on site. If so required as a profile, in lower profile and working profile, you have to record it. In that, it's not like a contractual management letter. It's not that. It's simply memos to contractor means contractors advise you do this. You have not done that. We are just write to you, remind you, you have to do which you have like that, letters and low profiles, or you can say talkative letters, or you can say letters that speak, means you should remember, and that engineer or resident must remember here, you should summarize instructions to contractor. Contractor must realize that it was contractor's duty to take care of that, but contractor could not take care of that. Then, then technical clarifications. Technical clarifications is very important one. It's because coordination. Because of coordination, what is actually clarification? Why do we need to understand this point by these explanations? That drawing is not produced in one day. It takes many weeks, many months to produce an original drawing, and for that, you have to coordinate among all disciplines of your buildings designs, which will be architectural, structural, and services, and all with that means by coordination or tripartite coordination or complete coordination. Everyone is in this stage. This is really professional talk here regarding technical qualification, and which if I just repeat and concentrate on that just to let you know what it is, how it is done, because this is major part of office engineering, a part of site engineering. Office engineering or site engineering are two terms which are very beautiful terms in fact, because site engineering is of course done on site, but there's a supporting system that checks everything before before whatever is done. Every project has many types of documents and drawings and designs. You can name like that. It is a structural one or maybe plan, whatever. There should be some architectural detail, layout detail, structural detail, services details, or some other systems or some other requirements and specifications, various classes of specifications and various agreements. All these are required to be studied before doing something. If you have decided to study and do something, you when you study, you will find different deficiencies because no drawing is complete. As I understand, everyone has last thought of even small paper to write something. That when you discover on your survey of these drawings, investigations of drawings, you're going through architectural drawing, you're going through structural drawing, you're correlating with each other, or some other schematic drawing or services drawing, or some other model you have. You are not finding that whatever you see in this drawing, same as regards to other drawings. This often happens because of many reasons. I shall not know details. When this happens, means your information is not reaching site that what should be done. If something is reaching, it either underestimate, and that underestimation is not helpful. This underestimation of your checking is not helpful. You have to read every document to coordinate and also specifications to know what you have to do. Otherwise, you will do wrong work. You will do whatever you are not, or you will hesitate to instruct on site because you are not clear about what to be done. There's a design deficiency, there's absence of design coordination, something in that, so that you as site engineer or as an office engineer are not understanding what they want to do. In that case, you have to know where but find find something if there exists which is not pro construction, and you have to chart out that among all time whenever you start something, because on many projects big one, all device drawings keep on coming, and it's your duty to go through all these drawings and find errors in those drawings. And being office engineer or being whatever responsibility you got somewhere else, you can communicate to all the engineers that this is what you are doing, this is what I was thinking of you, expecting of you, but that is not idea, that's gone. So once you start coordinating these drawings, various types of drawings and specifications, you will find various problems on that. Is there just architectural drawing, there's a structural drawing, both are not talking, both are not talking to each other. Either architect's mistake is there or structural engineer's mistake is there, or there's some other reason, there's some other problem existing in. And when you stick to the services drawings, the HVAC service or water supply or sewer line or rainwater or whatever like that, that what service is required, that space is not available, or some other reason is that, or in a false ceiling system or wall system or the system, you have to depend upon this drawing while working. And then there's engineering query. So this, once you discover that there's an error, there's something that has to be resorted, you make a query. I'll show you this query samples later on. You make a query to engineer as contracting representative, as contractors you can say, or if you are if you are in your say you're in consultancy, you may do that there also if you are researching yourselves. So each question is, if if you are not doing that, if drawings are not perfect, there's some deficiency, you have to pinpoint that one on writing, and that pinpoint is make queries, make site queries, and then API. And if you coordinate it properly, you'll find hundreds of issues in that, and that is where you are successful. That is where it's required to be done that way. So what I am saying here is that technical clarifications are important for work, whereas engineering clarifications are for prime work of design, where this involved means prime design is involved, and what is the criteria behind that means this I told you before, that is anti, or you may say they are titling anti-national. We are not titling that. I'm not going to that one. I'm talking about project related. So your clarification should be clear for everything. And then there's the engineering one. When there's a problem, people issue of these chats and these dramas. They don't understand that they're in quality. Quality has to be assured that way, means technical clarification and engineering clarification. Engineering clarification is most time related to design coordination. When there's something you can say design needs or doesn't need, so it doesn't go to you can say technical clarification only. It's the major part which technical clarification can be included in this, but this cannot be included in your clarification, your question. So when I did not realize I was traveling and I could not complete all that drawings, and so I have to sit together and do like that. When engineering clarifications, this must be in line to field requirement. Field, as we discussed before, FED, that is front end engineering design, because that is a part of your contract follow up. So we have discussed about daily progress report, we have discussed about memos to contractor, we have discussed about technical clarification, and we have discussed about engineering clarification. Engineering clarification generally taken up by main contractor to get some clarifications away, and then it is surveying. Surveying is most difficult. If you miss something, sometime you'll face consequences. After that, we have to go to contractual clarification. Contractual clarification. Contract document, we say contract form, contract specs, contract, what actually demands. What actually demands. That's the point you have to concentrate. I'm going to tell you this very specific management document that I'm going to do about supervision because it affects consultants, it affects engineer, it affects engineers and contractors and everybody it affects because high profile management it is. It's very high profile management, and there's a contractual clarification means there's something in contract, there's something in drawing, there's something in field, there's something in practice. That must be charted out if there's a conflict, if there's a clash. Contract clarification. And if that is not charted out and contract isn't agreed, that shall cause a dispute. Because ambiguity exists there. Then we go to, well, it's long term, then it's very difficult. In fact, engineers' clarification can be handled technical clarification. If there's a contractual clarification requirement, it's better if it's done before signing tender and before entering into some agreement, or else it will cause problem because employer shall have operand on you. Employer will get some water and some tea from here, and then okay, it starts. They forget fixing something which is required. So here is contractual clarification that you have to fix whatever was required in perfection. But because this is very boring subject, engineers may take it, okay, we'll see when this comes and that comes. Now we are not watching that. We are not taking into consideration. So contractual clarification is very complicated one. Then you go to request for inspection general items. Request for inspection general items and request for inspection for concrete posts. There are two kinds of reflex documentation used in connection work done and to be issued by after signatures of RE to us. So we can say general items means request for inspection. You have to write in advance that we are going to this day, and you can issue that inspection request to consultant or engineer, resident engineer. If you think you'll do that job, and that's generally we give 24 hours notice for that generally until the relations are fine with the contractor. Then anytime you can call the contractor, but until then, you have to follow certain procedures. In general, for ordinary items, non-concrete items, structural items, you say this 24 hours are fine enough. And then for your other part of that complete package, the services and this and plus transit one. This is you adopt this concrete pour submission of request within 48 hours. So ordinary item requires 24 hours for inspection, whereas concrete requires 24 hours. But these should be rarely used because we learn in field and everything is fastened there. So 48 hours notice you have to give for inspection of concrete element, major concrete element, maybe for some suspended slab or bridge or whatever you want to say. Here I just remind you about this is what I said, this inspections and other queries. Where you say you have to give speed of your work and you have to decide how to increase speed because consultant is also already busy in many assignments and there are many projects altogether. We have to be clear about that. Yes, in the start you have to do 24 hours notice, 48 hours notice for ordinary item, for concrete item. Yet once you have trust, you win trust of those people and they rely on to you and this trust is nothing. Then you come forward to non-compliance report, which is very powerful document, non-compliance report, non-conformance report, because it is ultimate requirement of project. Means if you are not accepting that, it can give disputes or many other corrections or corrections. You may say that, oh, I know this is no problem. Yes, you may know everything. You know everything, but still there is no result on sites. Still products are not coming quality products, are coming substandard products. Now let me stand for a while, let's say for half an hour, so that I can get my legs stretched and we can talk together friendly. I like to stay for a while. So sitting together pains my knees and joints. So let me talk like this in different position. And that is here. I was talking about non-compliance, and that non-conformance is that you are given drawings, you are given specifications, and you have certain written documents of your own or given by someone else. All these are engineering documents, means architectural drawings, structural drawings, services drawings, and codes. Of course, codes are not done yet. We consider also then method statements that you agreed with engineer and engineer agreed with contractor. We all have those documents and we have good construction practices. This means we have certain target. We have to comply with that method, which is our heart, which is our mind as engineer, as contractor, as public. Public expects that. But what happens? It is habit that site people, though they are given all documents in time, even if they are not given, they must have experience of that, they must have knowledge of that. These side guys, sometimes they are too tired or there's so much workload on them and there's so much pressure on them that you have to do this, you have to do this, and you have to do this. There's a pressure on them, pressurized community. You have to finish this concrete today or night you have to finish this. You have to finish it immediately because tomorrow I have to start this activity. This means directly or indirectly, they are pressurized. They know what to do. This doesn't mean they don't know. Yet, there is some lapse. there is some lapse discovered by either site guy themselves or quality person who is also responsible for this project. But quality person is responsible for command of quality, ensuring that quality work has been done. While job of executive guy is site engineer or project manager is to ensure that work has been done according to requirement, according to decided quantity, and according to required management of quality implementation. Both know their jobs. They doesn't mean but there is lapse. There is lapse. If that lapse can be immediately you can say repaired to required status of system, to required criteria, there's no problem. What happens? Lapse results into defect. That lapse caused on site results into defect. Whatever type of defect. It's not simple one defect, it can be any type of defect in whatever type of activities we do. We are doing form work, we are doing steel, we are doing concreting, we are doing this, we are doing and then whatever it is. But defect appears by hook or by hook or by whose mistake it by whose mistake. I'm not talking about that. Once that defect is discovered, is noted by both by site and by quality guy, quality from contractor or quality from engineer, that person, that defect requires its rectification or its remedial. Means a remedial action is required to be done on that defect. Remedial action means concrete or that material should be brought to its intended quality standard from substandard defect. This defect is substandard, is lapse somewhere. And that cannot be done in 1 second, or that can be done just by magic. That requires certain process that's called remedial action. So for that defect, you have to start somewhere. You cannot say maybe you are there or not there, site guy is there later on, but that defect must be recorded somewhere. And that defect record means on document, and that document is called non-conforming record, non-compliance record, NCR, non-conformance record. That's very important. Once it is opened, it's recorded, it means complete details of that defect are recorded in that element or this reference that requires then method statement for repair or for remedial action. And that method statement must be approved by engineer or resident engineer or consultant and by contractor. And then compliance should be done. And then reinspection. And once it is satisfied by both contractor and engineer, that action has been taken and that defect has been rectified, removed, and material produced or concrete has been brought back to required quality mark. This document is closed and this is called NCR. And remember, until this defect is contained, concrete quality is brought back to its required standard, payment cannot be made for that part and its follow-up parts in sequence. Whatever activities to go on that is risk. Either you do not do that or you have to do on your own risk, and that is if it's not done, that payment cannot be made for those activities you do. So this is very risky and you have to be very careful about that. That's what it was, non-conformance documents. Then we can say that there's another one, and that is Material approval request. There are so many materials on every project, building project or facilities project or some other projects. Materials from all disciplines of engineering, electrical, mechanical, civil, IT, and furnishing, and many more. Hundreds of materials are going to be used on that project, and these are permanent materials. Permanent, including materials, means permanent use materials. Once goes to that project, cannot be taken out. These are neither temporary, non-preparatory, nor preparatory, but inclusive. These shall be there on that project until that project resides, that project works, and until that project serves. These materials are required to be approved on contract. You cannot say, I use it because I like. No. Somebody has to propose this material according to specifications, according to contract conditions. If there is a list given in a contract that you have to opt out this material from these options, then you have to stick to that, adhere to that. Or if specifications are given this specified material to bring, then you have to propose yourself. So if there is a list available in contract, the 3 or 4 references are given, you have to select out of this. You have to bring only from those defined or listed vendors or material producers or manufacturers. You have to propose those, and their varying qualities, there means is catalog references, etc., and considering timely delivery, and if there is any tests on that one, complete details you have to submit on standard forms of material submittals to your resident engineer, and then to through that to engineer, and then through honor. This must be approved, and you have to be very careful keeping your schedule when these materials will be delivered, because you have to place order for these materials before that time of inclusion onto work. You have to keep in mind that how much time you take in your company to place order, and what's manufacturing or availability status of the materials, that there should be no delay on activity. That's purpose of material approval. So it's very complicated and controllable item. You have to control price, you have to control everything, and delivery period and specification compliance of that. So that is material approval request only. After that, that is material approval, and then that's material placing orders, and then materials procurement, all this. And if there's a delivery problem, you have to put alternative submission. So this is very complicated exercise and procedure that can support delay your project if you're not careful about that. So as much as possible, you have to submit these materials in time so that you can place your orders for production. Then there's a drawing approval request. Similarly, on same patterns, material approval request, all drawing you have to listen, because there are many classes of drawings in every discipline. You can say drawings which are just for information, drawings just for construction, and drawings for work, and drawings for shop. Various types of drawings are here. Generally, information drawings and construction are issued by designers, where are drawings which are just for purpose of in details working, depending upon materials you are bringing in, or sizes of room, or what circuit you are following, electrical, and how you are designing your HVAC system, or if you are doing something else. Means these are drawings which cannot be directly produced by designers, but these are functional drawings. Means what your workshop, how to fabricate and how to work on site, those are called workshop drawings or working drawings. And shop drawings and fabrication drawings, those drawings do require to be submitted after you have worked upon them, because those shall be given to skilled artisans or your tradesmen to work in shop, workshop, on site. That's called drawings approval request. This can be design drawings also. Remember, it's EPC project. It's design drawings also would be, you can say, architectural, structural services or other drawings would be required to be approved in case it is EPC. So drawing approval request means there will be hundreds of drawings in each discipline, hundreds I mean to say, plan drawing, then standard details, then detailing and specifications and many more. You have to be very careful about this. Actually, these are practical experience I'm sharing with you. It is just very small talk I am making to you in this regard. There's so much in that. So much work is required in that. I just give an example. This is example. I was on a project, Italian project. It was in 2000 to 2003. Was there for 3 years. And this ethylene plant, 600 KTA. I was involved after some dispute on site in office engineering. I was given all these kinds of works activities, means I had to coordinate these drawings, I had to solve problems, help them, all engineers, many engineers were there. Site technical queries and shop drawings, and you can say site, and you can say many more method statements, for example, and miscellaneous types of activities were there. There was a question concerned about chambers, means underground utilities chambers. Those chambers means manholes of various services, oil services, water services, sewage services, and many type more, oily water, this water, that water. A big site, plant site. There were about, I can say, more than 400 chambers, manholes. And there's a plan for manager, project manager to precast them, because it's very difficult on site in that situation. There are thousands of people are working there and nothing is clear. Keep drawings keeping in coming, and projects are moving very fast. So they had to precast them. But precasting is not so easy, because these chambers have different depths, different sizes, and various inserts or blockouts. So what to do, how to do? There was one of my colleague who was expert on this. Oh, don't worry, I am expert on this. He was actually flyover engineer. Oh, say, I know a lot about this. I'm expert on this. If any difficulty comes, you come on to me. I help you. Oh, I heard him, no problem. Okay, thank you very much. I will. But later on, I saw, means it's not that easy as this block comes to. It may be 400, maybe 500, doesn't make a difference. It is engineering. You have to work it out. So what I said, I did not actually declare, I started with myself. I took up drawing and starting making working drawings for them. What I did, every manual plan, sizes were actually given, depth was not given, levels were given. I started taking one by one and working on each details, taking pipe levels coming from whatever direction, sizes of pipes and specifications required, everything. I started working on those drawings, means plan, then internal elevations, not external, I'm talking internal elevations of those chambers, which require depth of chamber, means depending upon level, what sort of top it should be, square or circular, and how many pipes are coming in and how many pipes are going out. What sort of outlets are required, because pipes cannot be embedded in those chambers. You have to leave blockouts for those pipes, incoming pipes or outgoing pipes, and there will be benching later on. Benching means separate activity. So we had to precast those chambers after casting to blinding on site. So I worked on all this. I started 1, 2, 3, means I took all this information from drawings, and where there's a conflict, that site engineer used to come to us and say, there's some problem I find. There's a site engineer on the yard. So I used to deliver these drawings after approval to site. Means of course it's a little difficult indeed. It's a detail because you have to go through all drawings which coming in, going out, sort of command of that results are coming in, then find what depth it is and whether step rises are there, not what sort of cover is there, so thickness of wall is there, and all that. Of course, in beginning it takes some time, but later on, when this was standardized one, I used to copy paste and edit, copy paste and edit. I produce all drawings and many clarifications required, site technical process are required because that is used to come to me and with this I'm finding problem in site and what able to do it. So at the same time, family used to communicate that problem to consultants, to engineers, who and resolve this. And they used to resolve a proposal. So now I'm telling you that of course, it was hard work, it was difficult work, but not impossible. Nobody discovered, no matter the problem inside, whether that precast 400 chambers, precast chambers, RCC chambers, pick of that. And then manhole details, manhole cover details. And they used to shift them from precast, you have to cycle excavation was over, blinding was over, just lay out and place them, install them and later on connection with pipe and filling inserts, all that is their site activity. That's what I'm telling you, that such types of design required. These are required on every building projects as well. Like I'm talking about RCS building projects, supervision. This is supervision of everything. Means you forget that time that you are site engineer or your office engineer or your consulting engineer. What your only target is solution. You have to solve your problem yourself. Too much conferencing, too much seminar, too much talk sometimes does not work. Sometimes you are yourself a conference, you are yourself a seminar, you determine yourself what you are going to do. That is more weighing than just a group discussion. Because whatever is in your mind cannot be explained to others, and it is not necessary what you explain to others, other guys receives that, because everybody has personality ego, everybody has every ego. Better sometimes do yourself everything and produce that and show them. It says in engineering sometimes result speaks itself, not a statement. So your produced drawing, which you works successfully in field, satisfactory in field, for that engineers works inside, that is what is explanation. And later on, same drawings were used, all drawings were used with of course little additional change as built drawings. That's what my experience I'm sharing with you. This is called engineering management. All right. Now, drawings approval, I have told you, it's a big job. And drawing approvals require a problem. And why it's a problem? When there's a coordinated plan. That is very significant one. Independent services doesn't cause a major problem on drawings. Independent service, I mean to say, there's electric circuit drawing on any floor on the wall. There's HVAC plan which is there. Coordination always causes a problem. Coordination means electrical services, HVAC services, or any gas services, or any other somewhere else services which is either passing through ceiling or through walls or somewhere else. That causes problem because those all services are combined and conflict somewhere where you have to recheck your design, you have to alter your HVAC size of duct, or you have to reroute your electrical conduiting system, or you have to redo something when your suspended ceiling or false ceiling do work there or erected there, or there's some almirah or cupboard in your wall, or there's something else that is very complex. And in utilities, further problems do exist. This is what I talk about internal, and this is the outside here landscape area. There are so many in plant utilities services. I told so many pipe work is going on, firefighting, gas pipe, acid chamber pipe, acid drain pipe, this pipe, that pipe, sewer pipe, rainwater pipe, soil sand, that and so much. There are chances of these services must be having different elevations, must be having different routes, different bends. There you have to produce a common drawing that is called combined services drawing, which should exhibit lines, coordinates, and levels of each utility. And when this is done clearly on that drawing, coordinated drawing, only then you can easily, comfortably, and successfully implement that, execute that, prosecute those services. Otherwise, if you don't have that one, you will stop somewhere after starting your job. Because there is some clash, manhole is coming, water line is coming, and sewer manhole is coming, and stormwater manhole is coming, or rainwater, or something would be somewhere be stop you. Because specifications don't allow you, rules don't allow you, so your work is stopped. And there is no answer what to do. Again, you have to go back to drawing and details and designs and labels and everything, and you have to reroute something. So you have to rework also on site. You work the excavate, you do lead service, then you have to remove it and do some other work. That is where wastage of money, wastage of material, wastage of time, you have to avoid. That is called coordination drawings, coordination utilities drawings, services drawing. Other one is coordination of internal drawings of how various services are running through room, ceiling or floor. And there are so much these days. Raised floor system is there. You have to go below ground level where your computer work is there. All services supporting computer system is there. So there are so many laboratories or so many chemicals are there. So much is there externally as well as internally that coordination assumes a great power in engineering construction. Then you go to temporary works, preparatory works, permanent works, and then you go to many other construction method statements, standard working designs of details, quality management statements, and safety management documents, and fire prevention suppression. So let us say temporary work. What is temporary work? What is preparatory work? And what is permanent work? What is temporary work? Let us talk of that. What is temporary work? Temporary work. Do you understand what is difference between temporary work and permanent work, and preparatory work and permanent work, and temporary work and preparatory work? Temporary means temporary. You have to withdraw that after use. Simple definition. Use it temporarily and withdraw it. And then you reuse somewhere else. For example, scaffolding. For example, ladder. For example, stair ladder. For example, safety equipment. Whatever that is just used and withdrawn after work is over. After permanent work is over. This is a relation between temporary work and permanent work. So what is preparatory work? Preparatory work is very significant because without that you cannot do permanent work. Example, you have to prepare for your item. You have to see what is preparation. RCC say. What is RCC? RCC component is a product of various activities like supporting system, for work, steel fabrication and placement, concrete placement. There are also so supporting system of slab or whatever beam or column or everything. That is what scaffolding, plywood or batten formwork. This all preparatory work. Placement of steel reinforcement fabricated one, that is preparatory work. But permanent work is procurement of steel, fabrication of steel and concrete. This is permanent member. Concrete shall stay there, steel rebar shall stay there, everything shall stay there, but their preparation is called preparatory work. Concrete is permanent material, steel is permanent material, but their supporting activities are preparatory works. So this is classification, this is a little difference which we have to understand. No confusion. Temporary work, preparatory work and permanent work. Actually, temporary work supports preparatory work and preparatory work supports permanent work. And permanent is permanent when preparatory items are removed and temporary items are removed. This is difference. This is generally on all projects. You work on foundations, you work in whatever activity, you work in stub columns or in superstructure columns or in beams or in slabs or wherever you work, on whatever activity you work, you have to use some temporary measures, you have to use some preparatory works, and then you have to produce permanent work. You are paid finally for permanent work, because payment for preparatory works and payment for temporary works is not made, but for your resulting work, and that resulting work which is going to serve you forever until that project work stage serves. That is called, these classifications are that. So we have to move little further on this, and that is what I say. Which page is it? Yes, no, it is. Let's say then, after that means temporary works, preparatory and permanent work have gone. We're going to construction method statements. You remember this, I'm talking about references in this page. This is all in clause 3, terms and definitions, control references I'm talking about for information. Construction method statements. Actually, this term is not clear to majority of engineers and majority of contractors. Of course, majority of designers. This is term which is very powerful but unclear. Everybody knows everything here. If you talk to someone, everybody knows everything. I have done this many times, everybody would say. I am taking responsibility, everybody would say. But in fact, everybody is void and blank. I don't understand reason why people run away from this small term, method statements. It is also called procedure statements in some countries, for example in France. Well, it doesn't matter. You have to produce a document that is known as a method statement or construction method statement, because we are talking of construction. If we talk of design, we will say design method statement, or if we talk of something, we would say that activity method statement. Here we are talking of method statement, which is in details for activities, and also there is a prime one that is called executive statement, executive method, and that is for whole project. How you are going to handle whole project from beginning to end, that is called executive method statement or executive statement. This is construction method statements, and particularly it is used for individual activities or a combination of activities. This means, somebody asked me long back when I was out in some other country, because they knew I used to write this very successfully. How do you write this? We don't understand. Of course, they would not understand because they never wrote it. Only that person understands who wrote it. How can you understand? I told him simple way. He was very big person. He was Lebanese guy. He used to come to me for all this. How you write this? Very simple, my dear. It's very simple. Don't worry about this. Just stand on site and imagine what you are going to do and write that. That's all. What? Yes. Imagine that I am standing on site, but you are not standing on site, you're sitting in office. It doesn't make a difference. I am in dream. I am dream on site. I am dreaming site. I am standing there. What people are doing, I'm writing, and that's called method statement. That I just ignored that one because of why to explain to those people who cannot understand this. Construction method statement means you have to write in various titles. For example, what is the scope of that statement, what material you are going to use that, what safety measures you are going to adopt for that, what are documents involved with that, what are references other involved with that, what way or what procedure is there, at what levels you will inspect that, and if there is some attachments with that, you have to include that. If there is some other way, you have to define that. What machines you will use to define that. How much, what strength of your resources, your human resources, or what is standard of approvals you have got, all that, what drawings you have got, all that contribute to production of method statement. This is complete engineering exercise accumulating to one point from designs, from methods, from purchase, from, you can say, drawings, and from experience to one page or one document you bring in and collect there in totality, that this has to be done on site. But it's not your mandate, remember. You are supporting site guys, so you have to talk in details with that site engineer or project manager or whoever is there, because you are giving a quality oriented service. You are giving a document that belongs to quality management. You have to listen to that one, that person, layman or foreman or general foreman, or who shall directly work on that activity. You have to take feedback from that and convert to your engineering language, not very difficult language, in a language that those guys do understand, and convert complete information into a professional working document that is called method statement. Is it that difficult? I don't think so. If you have worked on site, even though you are on outside, you know how activity is done, then you can know what resources are required. You can know how many, for example, what quantity is required, what are approvals, and where inspection is required, what precautions we have to take. You simply write that. It's not that difficult, but hesitation has to be overcome. Because you're not doing alone, you're getting feedback from others. You have available documents for materials, for drawings, all references are there. Scope is known that this item covers this activity. You have to just reflect that and nothing else. And that should speak itself. It should start from imagination and reach to delivery of that activity. That is called method statement. So can it be done? It's very easy if you know good English, I mean say working English, and you can reflect that into sentence, and other guy can understand that, and that's all. Yes, you can put in strength by giving your own mind. You can suggest in that, and side guy should agree with that. And it should not go against practice. Remember, it should be within limits of profession. It should not be out of codes. It should not be out of contract. You should not pay gold if you are just getting money for soil. You should pay soil only. That's you have to keep in mind. You cannot deliver free. That's why you are required to confer with site people and just write them like advocates write your case in legal language. It's same thing, and that's construction method statements. You have little experience of sites, 2, 3, 4, 5 years, and you understand what site says, and you can write. Same thing, it's no big problem. But problem lies here. Engineers generally run away from writing, I know. Engineers in all civil, electrical, mechanical trade, they run out of writing. I don't know reason behind that. Okay, you write in your language, no problem. Don't write in English, write in your language. Those people don't understand. You don't know that language too. Because it's our culture. We want to avoid writing. But remember, without writing, you cannot do anything. Once you are following quality system, that should prove your documented information should prove that you have done it. That is what is requirement of system. So construction method statements are professional documents that will constitute future records for you to prove that you complied with system. And in this country, this is missing. In our country, this is missing. People just do for verbatim I know this, I have read this, I will do. No document with them. And that is reason that communication is very poor on sites. What foreman is doing, supervisor doesn't know. What supervisor doing, junior engineer doesn't know. What that is doing, senior engineer doesn't know. What this doing, manager doesn't know. And there is no chain of quality management. And that is why quality drops. Ultimately, what guy is doing, nobody knows. What application of a vibrator doesn't, vibrator operator doesn't know. Just one applying vibrator, nobody tells him what to do or what not to do. Where pump shall be stationed, nobody knows. How many kilometer concrete has to come, everybody knows. But what is frequency of this truck, nobody knows. What is grade design, nobody knows. What is the curing way, nobody knows. They just go their way. That is why every activity requires construction method statement in black and white, in blueprint, for major items. I'm not saying that for every blinding, every lean concrete you have to write statements, but policy statement of that in construction way, in a form of method statement, you have to repeat that this is repetitive statement for blinding concrete or lean concrete. This is from form of columns, or this is from form of walls or slabs. And particularly for major pours or major activities, we have to give specific, dedicated, devoted statements giving complete details. How shall you do that? Timings of delivery of material, frequency of transit mixers, start time till end time, and specific numbers of workers, and specific numbers of pumps, sounded pumps, and specific numbers of value of slump and temperature and time, all requires to be given in that. That is called method statement. That is called technical statement of work. Then we move on to standard working design or details. Standard working designs or details. I have already explained that, yet you are given a package of drawings. You got a big package. Architect, structural engineer, services engineers, they have given you drawings. Take them and do. Can you do? You just take a bag of drawings and go to site and start working. Can you do that? Just you think yourself. You can never do that, believe me. You can never do that. Those people who issue these drawings, if you ask them, you do them, they won't also be able to do them. Because office work and site works are completely different. Completely different. Expertise is required everywhere. Those are experts of designs, but not of working on site. Whatever engineer they are. If you ask a designer, okay, take this drawing and go to site and start this building or this project, you think that can do? Never. Because that person is used to designing only. That person doesn't even know where coordinate is, where benchmark is, until that person researches for that, goes through all drawings and understands site. Then only that can do. This means these drawings are theoretical. Whatever drawings you get, hundreds of drawings and hundreds of specifications, these are all theoretical. This means every design engineer and discipline engineer have to study these in details and then reach a common understanding to produce other drawings, working drawings and shop drawings, fabrication drawings, and standard working drawings. Whatever drawings are required for all practical purposes, which would give implementation and prosecution of those activities, those drawings are required. Those drawings are generally called working drawings and shop drawings, shop fabrication drawings. Those drawings are used on shop for fabrication of HVAC ducts, for example, or fabrication of steel reinforcement, or fabrication of formwork, or fabrication of whatever activity is required. Those drawings all called fabrication drawings or shop drawings and working drawings. Different locations. These drawings are not limited to numbers. There's a structural drawing, you have to study that, and then you have sometimes require to do another drawing for purpose of site. Because site guys cannot take information from those drawings because these are design drawings. So structural working drawings, services working drawings, and all those working drawings consume a lot of time because your detailed working depends upon that. And then also standard design drawings, which are repetitive one. There are 100 locations on a project where the same details apply. That's called standard drawing. It can be national standard or it can be design standard of your own. You have to repeat them. So such type of working drawings, shop drawings, and design drawings do lot of work you have to do on them, and then according to them you have to plan, and that you have to consider into your schedule also. Plan schedule. You have to consider your timings also. So nothing can move in exclusion. Nothing. Design cannot move exclusion and site working cannot move in exclusion. Both have to relate to each other. Only then project can move, otherwise no. And then we have to talk about something like, that is quality management statements, including checklists and ITPs. So far we're talking on behalf of design and on site prosecution, execution, implementation. Now there is third one, which is called quality management statements. Quality, first we have understood what quality is. This is actually a confusing way to understand quality. Everybody has to work for quality. This is a requirement. Quality in designs, quality on sites, quality of management, quality of procurement, quality. Every work should be per quality requirement. But this quality, we are talking of work quality, production quality. What you do on site, every activity should be conducted according to project requirement, according to standards requirement, code requirement. But codes do not give working activities. No code mentions. That is unfortunate. No code mentions how to do activity on site. They mention about designs parameters, about some other parameters. Tester and they can give, but working no one give. It depends on quality and site guy how to understand that. Quality management is that system which has been inserted between designs and practical work or physical work. That is called quality management, which ensures that whatever work has been done is according to conformance of specification. That is what is quality management. There should be no time loss, there should be no money loss, there should be no material loss, but work should match test results and controls, workmanship and everything. And there should be no loss on quality of future of work. Means everything should be done according to requirement, and that is where quality lies. And person who is on site, that person is responsible. Person who is in design, that person also responsible. And person who is managing this, monitoring this quality system engineer, that person too is responsible. Because quality is not responsibility of one, it is responsibility of all. Just like safety is not responsibility of one, it is responsibility of all. Quality responsibility starts from lowest trainman to highest officer, highest engineer, highest manager. If it doesn't work, you cannot get quality, because if everybody knows job, that person is called quality person. If site engineer knows job, site engineer also quality person. If quality guys knows job, that person is also quality engineer. Like that, every personnel involved from lowest to key personnel all are quality guys. There should be a quality plan, just like there should be a safety plan, there should be a project management plan on site, or you can say project plan, there should be a quality plan. This quality plan must define something, some standards, and these are, it must say how quality work shall be done, what are job descriptions of people, of key personnel, how shall they interact with each other, how shall they monitor work, how shall they arrange system, what shall be checklists on each item or activity, what shall be format of inspection and test plans. All these are covered in that quality plan, and which standards are applying, which standard will be monitored, which way it is done. Everything is covered in brief and in explanatory mode, both in quality management plan for that project, which is a supportive document for that project, and that is very useful document. Every project has many activities. There could be, you say, hundreds of checklists or 50 checklists or whatever standard checklist for each activity, and there will be inspection and test plan accordingly. Which stage inspection is required, which stage inspection is not required, which is just surveillance is required, and where is a mandatory inspection is required. These formats do that. These formats require that all. Where is site engineer's confirmation is required, where is foreman confirmation is required, where is inspector of quality has to check, where is manager of quality has to ensure, where others required. This is called quality management, and this must be covered in all construction areas, RCC, structural steel, services, or finishing activities. All this quality management applies everywhere. It's not easy to just define it. It varies from one project to other project, but basics are same, mindset is same. Once you start this, you can repeat that. That doesn't make a difference. Otherwise, you will be in darkness and you cannot say the project is quality project. Once you train your crew of every activity, this can move easily. One, can you train yourself for writing statements, you can write easily. Similarly, quality engineer has to know what points or what stages that person has to inspect, and where he has to avoid non-conformance report, and where that inspector has to avoid because you have to avoid your problem also, keeping in view project status, project value. If something can be done by mutual interaction, that will be resolved on site. If you think that's going out of control, then you have to take a stern action. It is not mandatory that all time you fight with each other, because fighting itself is against quality management. You are collaborating with each other. You have to collaborate with each other. This means you have to solve problems, not create problems. If you all time think I'm quality man, I don't care for what you are doing, just give me that idea. That's not collaborative. You are also experienced and qualified. The other person who's doing jobs also experienced and qualified. So you have to respect each other in job interest, in work interest. Then we come on to safety management documents, including safety induction, training, upkeep, and surveillance. I have talked at length about this in many videos of safety. HSC, it's called health, safety, and environment and ergonomics. These URLs I have put in text form of every video. Of this one you can see, go to text of this video, you will find many URLs, and safety and ergonomics are also given there. You can refer to that. The safety is very important for activity, every activity. If you are not safe, you are yourself not in quality management. If you cannot keep people safe who are working for you, you are not in quality management. If you cannot keep yourself safe or others safe, your work shall result in accidents. And zero accident is policy on every system, though there is also falsification, I know. Yet policy is that accident should be avoided, material loss should be avoided, time loss should be avoided, hazard situation should be avoided, hazard should be controlled, That is where say, if you know safety, if you know safety, there is no pain. Means you have to work comfortably. If you do not safety, if you do not know safety, then you have to know pain. If you miss safety, you have to know pain, you have to undergo pain. That is where safety lies. So safety first means that. It doesn't mean safety top. It means first consider safety, then work. Let everybody should know safety, then work. Then everybody should know quality and then work. And then fire prevention and suppression, which is also a part of safety. Fire prevention is better than fire fighting and fire suppression. That is basics behind that. All this you have to know before entering into your site, that you can take control of this. And these are all mandatory documentations. These are not, optional. All this document, I will repeat that. These are mandatory for what purpose? Just like we studied now control references, I repeat these titles. One was daily progress report or status, that's called DPR or job report. Two is memos to contractors, and three is technical clarifications, and four is engineering clarification, and five is contractual clarification. Then request for inspection general items, and then request for inspection concrete posts, the non-gun compliance reports, the non-conformance reports, and the material approval request, and drawing approval request, and temporary works, and preparatory works, and permanent works. Then construction method statements, the standard working designs or details, and quality management statements, including checklist and ITP, and safety management documents, then including safety, induction, training, upkeep, and surveillance, and then fire prevention and suppression. These were documents so far we talked about. Now we are going to something else, and that is supporting references. Now, supporting references are not actually such documents, just are some different way. How to do various activities, how to do that, those references must have in different form, and those are very specific for all structures. Let us say titles of this. We say excavation, for example, then soil testing on site, then soil improvements, blinding, then concrete protection, waterproofing below ground and above ground, cast in situ concrete, formwork, reinforcement fabrication, reinforcement placement, precast pre-stressed concrete if included, concrete glass, reinforcement grade, soil backfill, piping, concrete block walls, roofing, plastering or rendering, flooring, doors, windows, ironmongery, kitchens, wet areas, finishes, special items, testing and commissioning, design, estimated quantities, issued for information drawings, issued for building permit drawings, issued for construction drawings, revised drawings, national annexes, nationally determined parameters, published documents, and all other necessary definitions. This is all in clause 3. We are talking, still I am on clause 3 out of 10 clauses. And in addition to what we previously talked about of technicalities of documentation, now it is for something else, means we should have all references regarding these activities that are, I just explained now. Excavation itself is a big activity. Excavation. Do you understand what is excavation? Is it only using machine and excavating or something else also? This is also very important. People consider just bring JVC and excavate. That's right. That is physical activity. Physical activity like means, okay, I excavated, that's it. But did you think before that? That's very big point. Did you think or just excavate? If suppose there is an electric cable below that, you will excavate that also. If there is a water line, you excavate that also. There can be any kind of service in that, live service. Can you do that also? That is what is important to think about. Yes, excavation is very easy. On projects, yes, you can see and anywhere they will find every project and people are not worried about this excavation. And they do everything possible to damage everything. They are very dynamic in damaging services. Very dynamic guys here. Excavator, JVC operators and people. Least bother about anything. Sewer line is passing, no problem, let it break, we'll put it again. We'll do it again. Do it again is acceptable, but not protecting it. Yes, I know there is no system here. No record drawings, no as-built drawings. So how shall someone know? That's the point. So do it. Whatever is done, do it. Really. But what should be actually? That's what we are talking. What should be done? Professionally, if we are a planned country, if we are, you can say, monitored nation. Okay, I am talking of all countries. I'm not talking of this country only. We may be having something or we may not be having something, but whole world is not going to learn from us. You have also to see that. Profession means world profession. When I say engineer, this doesn't mean constrained to our country. It means constrained to every country. Every country is much more organized than what we are. We are in fact unorganized nation as far as engineering is concerned. We just decide at random and at 11th hour we find some problem. This is our nature, this is our blood. But when we go to some other country where everything is organized, how we can accustom to that, how can we mold ourselves to that condition, and that is admirable. That's really appreciable. There we do, here we enjoy damaging everything. I have seen here activities are going on from various top class companies. They call themselves top class. For example, L&T. L&T is top company. Many other Adani companies are there. They call themselves top. But come on and see yourself what sort of work they are doing. Sometimes I feel so upset. That engineer comes, I'll slap on his face. Or even whoever comes, bloody, you do not know engineering and you are engineer. Your staff is working like donkeys and foolish people. They do not care for safety of public. They do not care of quality of concrete. They do not care of anything. This is a small work you are doing. But of course, on the mass scale, you are constructing stormwater drain boxes. I know what sort of design you are doing. Rubbish quality of stormwater box they are making means there's about 1.2 to 1.5 meter width of box and say 1.1 meter to 1.5 meter depth of that box is a completely closed box with certain external pipe connections. They cannot even deliver quality concrete for this below ground activity. How do you expect them to deliver you structures, building structures and other structures? I'm really surprised. It's not their fault, I know. It's not company's fault. Company is spending money. How can I say company's fault? I would say it's fault of engineering community. Engineers working them. They are wrong, not manager of that company, not owner of the company, because this is not their job. Control of engineering activity is job of engineers. If they do not do, if they do not kill, I cannot blame someone else. If you cannot control activities, if you cannot deliver quality work, systematic work, organized work, who can be blamed? We can be blamed. Only engineers. Because we know this job. I can't expect owner of that company know this job. I can't expect certain politician know that job. Only we can do that. But if we don't share our responsibility, we don't do that. We spoil everything. We don't care for public safety. We don't care for quality of material. We don't care for how work should move. We just do where we want to do something. and leave as it is to public inconvenience. You excavate something, okay, you are transporting it, okay, then you backfill it randomly. So where is engineering? Have you left engineering in university? I'm sure university doesn't teach you engineering, they teach you theory. Who shall teach you site work? You have to learn yourself. You have to manage it, but it's not done. Excavation, for example, I said, there is no system of recording any services underground utilities in our country, but this exists in other country. You go and go to see Middle East or Gulf and break some electric cable, you will know result. You'll be put behind jail. Go and buy bars, and you'll be penalized. Workshop is stopped because there are such conditions. It is duty of manager or engineer, whoever is there, to first get complete existing services information from official bodies or statutory bodies. Those may be authorities dealing with that service, or that may be municipality or some other local body who deal with that sort of services. You have to get recommendation from your client, from your owner, that this project has been started and we require to do this project for which we need records of these utility services. You will get that. You have to ensure that in which area you are going to excavate, nothing of that sort lies. And if there is something, you have to manually excavate that, or hand excavation you have to do first to ensure what is there, what extent is there. And if you think there's some technical problem, you have to contact that department and then discuss with them how to resolve this. Whether that department say we'll divert this service or will protect this service, or you have to protect this service according to your contract. Then you have to take care per given direction by that department to protect that service, or if it's required to be diverted, that department shall take care of that and divert that one. After that only you can go to excavate that area freely. That is what is called excavation management. It's not simply that I've done this. So there are two issues. One is record drawings, red lines, how to know safe or not safe, and then safety of excavation. You are going to excavate 2 meters, 3 meters, or more, or whatever depth. What sort of soil is there? What sort of strata is there? You should know. You may know it from your soil records for soil investigation, or you may know yourself. There can be rock, so no need of much worry, soft rock or hard, or there can be clay soil, there can be sandy soil, or there can be waterlogged area, or there can be, water table higher. Everything you should know before attempting to do that activity. You have to know which area, which building is existing one. Maybe there are existing buildings where you want to excavate, existing structures are there, or it's free site. Every point you have to take into consideration and then plan excavation. So existing structure should not be impacted upon, should not settle, or if it's free, you have to find access to that area. That is called excavation planning. We have to see how can we access to this trench, how can we come out of that trench, and what area of work we want, or we have to use diaphragm walling or something like that. It's your decision. You cannot simply go blank. I've done it. No, you have to think all this and then decide for excavation. So this is not children job, this is experience job. Maybe there is no border to work in your working area. You have to use diaphragm wall sheet piling. That is what you have to decide. So this also constitutes part of writing excavation method statement, that you have to get approval, or you have to approve yourself for purpose of execution or prosecution. Excavation only results in many accidents sometimes, and many clay soil collapses sometimes, or silty soil collapses, or even sand collapses. There's a much less angle of repose, so it's a difficult one. Yeah, and this water level is there, then you have to pump out that water level. You have to keep area of formation dry, otherwise you cannot proceed forward. Maybe you have to go 3 meters or 4 meters or 5 meters in depth. And water is there. It is sandy soil or clay soil, and you have to allow for bailing out of water. How shall you do that? You have to know about that. That's also very important. You may be having to use some pump or submersible pumps or on-ground pumps or some other decision. It is clay soil. You cannot take turbulent water out. Water flow is limited. Then you have to install well point system. That's very slow. Round clock it should work. Then you have to take water out through these well point systems. It's not clay soil, it's sandy soil. Then you have to install submersible pump in some at foundation level and keep it out when it's filled and take it out to a manhole. All this you have to see. You have to keep your area dry of water, otherwise you shall not be able to concrete that area, and until concrete is done and comes to ground level, you cannot, then you can release that water, because there is enough force in that area of your foundation to keep that water of a thrust out. All these points are excavation related points and also safety related issues, because depth of trench is high, there are chances of collapse of soil body. There are chances of settlement of vicinity buildings. Even a distant building can be impacted upon when there's a water flow through pores in sandy soils. It can happen. Soil movement is there, chemical of soils movement is there, subsidence can happen. All these points are engineering issues. But here, nobody cares. Go and see, oh, no problem. Let it move in the name of God. Very easy. If there's some problem, oh, some ghost came, something happened, and it was a result. Very silly answers. But this is not engineering answer. Engineering answer is study it, plan it, do it, check it, and act. That is what study is. PDC. Think, plan, do, check, and act. If you can do that, that's fine, or forget it. What else can I say? Forget it. Nothing to do in that. So what to say then? Now, excavation I was talking of. There's so much you can talk about excavation. I cannot talk all that. If excavation is successful, then your activity is to go up. That is a normal one. Don't forget what it says, soil testing on site. Once you have excavated safely, it's going on, then you have to test soil. That's also very important. Soil testing. You have to ensure bearing capacity of soil. There's a definition in your specification that soil should be this much strength for this design. And designer has taken that into consideration, that bearing capacity of soil or shear strength of soil or whatever else should be this minimum, or piling has to go in, or what sort of foundation should be, has to depend upon soil bearing capacity, or this foundation we have taken into our design depends on this limit of soil strength. So you have to ensure that. How to do that? You should say, how can I know that? No, you have to do that. You have to conduct soil test on that. If it is rock soil or sandy soil, you have to bring that truck, load bearing truck, where reaction method is applicable. When plate is put on that, you have to know that value of K and get bearing capacity. You have to do that. Once you ensure that bearing capacity is tallying with requirement, you can continue, or else you have to find ways, and that ways you have to upgrade that specification of soil, whatever is available on site, you have to improve that, and that's called soil improvement. What is soil improvement? All of you know it, I know theoretically. How it is done, you have to read all applicable methods. There can be adding layer of graded material by removing all weak soil. You have to remove weak soil. It may be half meter, it may be 30-40 centimeter, it may be 1 meter. It depends upon what your borehole tells you. You have to remove that and fill in graded engineered material to that level. From level you excavated to, you removed weak excavated material. You remove that material from weakest level and you have to fill back with graded material and then compact it in layers and test field dry density. And of course, you can conduct another soil test of bearing capacity. That is what soil improvement is, and for major structures it is done. I'm not saying for small buildings you do it. You can improve soil for a small building, of course. You can use graded material for 2 or 3 or 4 layers and increase bearing capacity of that. It is in national interest, it's in your building interest. It's not very expensive, but you can do that when there's a question of clay soil or silty soil. You must do that, because you have to ensure that water should not be stagnant there. If water is stagnant below foundation, it is difficult for that. There can be question of swelling or something else, and there can be settlement or some other problem for building. So we have to be careful about that. So soil improvement can remove this problem, can eliminate this problem, because a graded filter, a kind of imaginary road has gone below building, where water can move freely without any problem, and it doesn't affect foundation. And even in vertical sections you can use same method by filling where clay soil exists, permeable material where water can move throughout without affecting structure. So this is called soil improvement, and there are many methods. This one I told you of grading, engineer fill, or you can use some other defined material or some other defined method on your drawings which your designer has taken into consideration. These references are involved, means whatever I'm telling you, these are all based on your references, what you have and which references you want to use. Then we go on to blinding. Blinding. What is blinding? Actually, you can say, all you know it, you call it lean concrete, I know. But lean concrete is only quality of concrete, it's the strength of concrete, it's nature of concrete. Oh, what is blinding? It is a surface treatment actually. Formation surface treatment. You can say surface available at formation level that's uneven. You excavate it, you test it certain level, you compact it as well using plate compactor or whatever means, or even taking it down into formation level when it's raft or whole excavation or mass excavation. You can take down your roller and compact that area. And you think it's done? Yes, it is done. But that one is also not in perfect horizontal layers. There are valleys and some other depressions or mounds. But your top of formation level where bottom of foundation axis or shall stay that level and this level uneven layer you have to fill in by a concrete of lower grade, maybe M20 or 25, and that concrete layer is called blinding. Means it's going to give you a regular surface, a smooth surface, and all unevenness is gone. Blinded. So that is called blinding concrete, which gives you a level surface where you can lay your concrete protection membrane, or you call waterproofing, whatever you call that. Then you go on to concrete protection, waterproofing below ground and above ground. Let me sit down for 5 minutes. Now, because I just talked of that, waterproofing or concrete protection below ground and above ground. This activity is very different. Here, actually, there's a confusion on this. Somebody says waterproofing, somebody says just have a bituminous layer on that, somebody says something and somebody says something else. Confusion. Actually, when we are using foundation item, concrete or even block, though we are not using block here, we are using brickwork. But remember, in soil there is water. In soil there are chemicals, sulfates, and many other chemical chlorides could be water chemical itself. And water keeps on mobility within soil strata. Soil strata is never constant in its properties, whatever sort of soil is there. Minerals are there, chemicals are there, other contents are there, and varying particle sizes are there. There can be minute particles, say clay particle 0.002 mm. There will be silt particles 0.02 mm. There could be sand particles, fine sand particles, or some other particles. When water is in mobility, it moves, we call mobile water or movement water through pores of soil. If it is passing to move, it takes within these minor settled particles, or if they are all settled, erodes them, and these are dissolved in suspension in this water, and these keep on moving from one location to other location. This means water particles are moving, water is moving, chemicals are moving, minerals are moving. These can touch bottom of your foundation, sides of your foundations, top of your foundations, and also all surfaces of your columns, step columns, which are embedded within soil. Don't you think this can harm this concrete surface? This can harm your concrete surface if it's not protected, because these are sulfates, these are chemicals, these are salts, these are water contents, minerals of them. You have to protect them from some application, and that application is called soil protection, concrete protection from soil act, soil attack, and some may call this waterproofing, because water is also moving there along with soil particles, soil minute particles, suspension particles, and chemicals, and so on and so forth. You have to protect your concrete surface from these attacks, and that is where we provide bitumen membrane or waterproofing membrane, whatever you call that, on all concrete surfaces in contact with soil, bottom of foundation, vertical sides of foundations, top of foundations, and all step column surfaces until plinth level. We have to do that, and that's people call waterproofing, they call concrete protection. This is below ground and above ground both. We'll talk of that later on in our method statements. This is just I am informing you what is purpose of that. But remember, that application of waterproofing is only limited to few years. It cannot continue for more than that. That is the reason we want to protect this layer as well. We have provided this layer. We said okay, but we have to protect this layer from impact of soil itself, because soil 1 meter fill or 2 meter fill shall have certain horizontal pressure and resultant pressure, and it can damage. There can be minor particles that come in contact with this bituminous layer. It will puncture this. For that purpose, we have to protect this layer as well, and that is, you can say, thin ply you can provide there, commercial ply, or some block work there around that, or brick work there around that. Whatever you think it is more durable than this, I would support either hard this flexible material is provided or block work is provided to be in touch with these surfaces, and this protection layer should be between that concrete surface and water surface external portion. It should, this membrane should be between two, so that there can be no effect on this membrane, and membrane can serve protection, protecting this concrete for longer duration, forever. That is purpose of this concrete protection, and this is for ground below and above ground. For both it is different type of specifications. For ground above also it is done, because concrete is there, it is done in some other form we will discuss later on. That's in paint form or application of something, whatever way it can be done. So that is called as the cast in situ concrete. As I said, concrete is either cast in situ, or all that. It's pre-cast or pre-stressed or cast in situ, or many other ways are there. We are talking of cast in situ concrete, which is best way. In fact, if you can do it under quality control, this is best way, because you may need to work every activity on site in this under direct control of your management. You can do on site preparatory works, you can do on site temporary works, and you can do on site permanent work. All must move here in cast in situ concrete, and you can ensure quality of that. But concrete activity is very difficult, hardworking, and you need concentrate to control it if you want this cast in concrete, because you have to ensure complete technical work on formwork, complete technical of reinforcement, complete technical work supporting works, complete technical of pouring and post pour cure. All these are engineering applications that require your knowledge, your experience. Any error, whatever minor error, can cause a problem. Tolerances in plumb, tolerances, sizes, dimensions, cover dimension, reinforcement placement, everything requires to be within control, and concrete how it is done. All references are there. You have to go through those references. We will talk them in details later on. Now go to form work, which is same as I explained. It should be to dimensions, it should be to vertical plumb, it should be in orientation rightly from axis where you consider, and it should be perfect, well supported, well bolted if it's vertical form, and well supported vertical if it's horizontal form. All types should be according to your drawing that you prepared for preparatory works. That is very important. You have to ensure where moments are coming, where loads are coming, where there are chances to open these sides automatically, or where the chances that there can be movement. All these points you have to consider in these references. You can say reinforcement fabrication. Yes, reinforcement fabrication and reinforcement placement, very, very difficult activities. if you don't know that. And if you understand that, you know codification of that, you are using British standards or you are using your own standards. If you have formalized that dimensions on Excel sheet or somewhere, immediately you can get cutting lengths if you formalize that. If you get cutting length, then bending is not a big problem. It can be bent like that because cutting length is difficult to calculate. And then placement is according to drawing, so you know it can't be explained. It's up to you to do it yourself, to understand which bar should go first and which bar should go second, and how we have to do. We have to prefigure the ground, we have to take it there, prepare it, or we have to do work on location itself. That is what you have to decide. There is no hard fast rule for that. You can do yourself. So many bars are done on site and cut on site. So many are prefabricated, particularly beams are fabricated and hang on by crane, placed on locations, and this continues. Then is precast, pre-stressed concrete, and that is also very important. Let me see what time we have now. It's already 3 hours 21. I think I should not take much of your time. It's also festival today, so better I want to close it earlier. I think I should. Well, let's talk a little and do it. Yes, yes, I say that precast and pre-stressed concrete. If we include that, how to do that? Precast and pre-stress means slab panels. Hollow core slab HCS, that's called hollow core. This can be done in workshop or in factory or in yard by steam curing, by pressing, by whatever way you want. These are very perfect in quality, these precast hollow panels, but these should rest on cast in situ beams, which should rest on cast in situ columns in the best way, keeping in view keeping in view seismic possible stresses to act upon them. Best way is to that. If you can understand this, this is faster. You can avoid side slab work, side suspended slab work. Columns and beams on which these precast slabs would rest are not big deal. And these precast slabs we are going to fix in, this must be connected together by diaphragm formation. Slab diaphragm, which is thick concrete RCC concrete on top of that, with many arrangements of connections to these columns and all interconnections among these precast panels, so that this whole becomes one slab, a diaphragm, and it takes horizontal forces that are expected of this in addition to vertical forces. Then concrete glass, then reinforcement grade, concrete glass, concrete what sort of glass, is grading of concrete, and it could be different types of concrete these days somewhere, but in general it is grade of concrete. We are talk M25, 30, 40 means depending on what sort of this, if it's high strength concrete for pre-stress work, or it will be high density concrete for your gamma rays in reactor, atomic reactor, or it may be some other sort of concrete. It depends upon that. Or it may be fiber concrete or pavement. It can be some other type of, it may be red oxide concrete, for electrical ducts, or for some other ducts, green concrete, green color concrete. There are various classes of concrete that we'll go through. Then reinforcement grade 415, for which so many gradings there, which is known to everybody. Need not explain. Books are available, catalogs are available. Soil backfill, that is a point which requires attention. Soil backfill is very important activity, though it's backfill they call it. It's not valued that much. It should deserve, but it is done. It is very important activity that we'll take up later on also, because it's very activity which needs from technical point of view. If backfill is not done in a professional way, there are chances that in future your foundation may settle, or your some other structure may settle. If it doesn't get that much fill dry density as it should have, then the piping below fill within fill itself, which piping have to move, and what you have to do, how you have to do, all that shall be discussed in this reference. And then concrete block wall, which are very important. If you don't consider brick walls, concrete block walls could be load bearing walls or not load bearing walls, could be infill or bonded walls in long areas, long walls. Means what sort of block wall you should use, should be reinforced or not reinforced, what strength of block wall is required, how strength of block is ensured, and all that we will take into reference. And then we'll take into reference roofing, upside down roofing, inverted roofing, that's called, how it works, how it functions, that's also very important. Then we have to take care of in this reference plastering, which is called plastering, as well as rendering. Means there's a difference in these two terms, plastering and rendering. Plastering is internal area plastering, and rendering is the external one. This is different term. Rendering with external plaster is always thicker than internal plaster, and external plaster is always more resistant to weather, to temperature, to thermodynamics, to moisture. And then different types of floorings, which are very important in this computer world: raised flooring, normal floorings, and door, windows, and iron only references, and then kitchen equipment references. And they'll see wet areas, means kitchen, toilet, bathrooms, all that, where water comes in contact, how you should deal with that one. Then finishes, and general finishes for decoration purpose, and we'll take up special items. And then further on commissioning side, pre-testing, pre-commissioning, testing and commissioning, and then design estimated quantities, and then issued for information drawing, issued for building permit drawings, issued for construction drawings, revised drawings, designs, national annexes, then nationally determined parameters, published documents, and then all other necessary definitions which have not been taken care of in this. This we will take up there, as I think this document has still one third we have gone through this documents. So we will take care of that one in further discussions, because these are very important. If we do not go through this, we cannot understand what engineering is about. Engineering is not what is done on site and overseen, done concrete pouring and finishing it. It requires backup. And that what we have learned. Our engineers need to read all these, whatever the information they have from whatever source, and then decide, because they are responsible for that work. No one is else responsible. If they cannot withdraw themselves from this, if they withdraw, means they are not engineers. How they do it, it's up to them. They may work in government or they may whatever sector. This is their job. Our job cannot be taken or superseded by someone else. There's no manager who is not engineer can take up our job. There's no MBA who can take over your job. They have only this time for their activities, the limited activities. But engineers' activities cannot be called limited activity, because your activities are always divergent. You cannot stay at one place and say, no, I have to do this. You are mobile mind-wise, you are mobile physique-wise, you are mobile travel-wise. You have to remain mobile for confirmation, for announcement that this work is accordingly done in compliance to this document or that document, which is much more important. And you have to claim that. It's not simply hesitation. You have to claim it, that it has been done accordingly, and it serves that purpose, because ultimately you have to certify, you have to supply compliance of this document, compliance of the specification, compliance of designs, compliance of this and that. That's all where everything involves, and this is where you are involved. So I understand that you get my point, and you will keep the supervision document annex SL. This is a very important one, because this is related to you as consultant, this is related to you as site guy, this is related to you every quality person, this relates to everyone, and everyone should understand what lies behind supervision. It controls execution, it controls design, it controls everyone, because it is affected by all, for all. Everyone has to understand this type of requirement and where we stand. So I'll take your leave now and close this for for tomorrow or some other time when it is, because I don't know it's more time today. And thank you, gentlemen, who has joined this. Who has joined this actually? I don't know. Deep, welcome, Mr. Deep. Thank you very much for joining.